Hello and welcome, and sorry for the slight delay for the ones online. So let's just get this thing going immediately, because we are behind schedule. So first of all, I want to thank Kilian for coming here, and he will talk about running web with Dart, not Flutter. So a big round of applause, thank you.
Thanks. I'm glad that it's very loud. At least some of you made it down here. It's kind of a weird way to go down here. Let's start. So I'm going to start with a little bit of a hot take. Building websites suck. I guess many of you feel the same way. We all love Dart, we all love Flutter. Maybe we've touched a bit of web development, maybe not. It's not a nice place to be in. I speak from experience. All the bundling and especially JavaScript. No one wants to do that. So I found my way first from web development to mobile development with Flutter. And while I always liked the web platform, I never really dug web development in its state with like JavaScript and all that stuff. So I was thinking to myself, why can't we build websites with Dart? And the fact was just that there wasn't really anything to do that. So kind of two and a half years ago, I started building a little project, like a little prototype myself, to try and use Dart for building websites. And that became Jaspr, as it is right now. Jaspr is a framework to build websites in a familiar way. That's like the super condensed short pitch. What I mean by that is threefold. So in a familiar way means one, of course, you can use Dart. So the language, but also the whole ecosystem. You can use Dart packages. You have your existing development setup that you can use. What it also means is if you come from Flutter, Jaspr will feel very familiar because it's built on a lot of similar concepts that Flutter has. And if you read Jaspr code, you will see that it kind of looks like Flutter. It's not really directly Flutter, but you will at least understand what's going on. And it is really designed in that sense. Then building websites. It's not like Flutter kind of painting pixel on a canvas. It's actually rendering HTML and CSS. So you will build real websites. And you get every benefit from that, like good SEO, good loading, in general, good performance of your sites. And the third thing is a framework. So Jaspr is not an extension. It's not kind of a fork of Flutter. It's really kind of a separate thing. While it looks familiar, as I said, it is its own framework. It now has, I think, 10 packages, like made of 10 packages. And it has kind of its own concepts also that made it up, and like its own good practices. And yeah, so I'm Kilian. As I said, I'm a web developer turned Flutter developer turned web framework developer, kind of. And this is not only me on the picture, but this is also my dog, Jaspr. So that's where the name comes from. And he loves hiking. He loves, actually, he's great for debugging. If you know rubber duck debugging, I do Jaspr debugging. It's great to have someone you can explain and talk your code to. And I want to go in this talk a bit deeper in look under the hood, how Jaspr works, maybe give a few insights, compare it to Flutter, and just generally see what does it take to build a framework like that. And when I started out 2 years ago, this wasn't intended. I never sat down and say, hey, I want to build this super big thing. I wouldn't even know how to start. So maybe if you're also thinking about starting something, building a package, you don't know where it will go, maybe just start. I didn't know all that stuff that then came afterwards. I just sat down, made a little prototype, and then it grew from there. And you have to put in some time and effort, obviously. But I think everyone, don't be afraid to just start something. So, how does a component in Jaspr look like? You have the component class. It's actually the same as a widget, just in a different name. So you have your stateless components, your stateful component, your inherited component, and you can use it the same as with widgets. It has a build method that also kind of has a similar purpose. The major difference is instead of returning one component, you can return multiple components. So here it's actually an iterable. The reason for that is because in web with HTML, every element can have multiple children. So that was one decision I made to kind of diverge a bit from Flutter and say, okay, we are on web now, we're using HTML elements, so it actually makes sense to kind of make this change to be more near how web actually works. And this is also one kind of design principle I decided for Jaspr, that it should look familiar, but still I don't want to kind of compromise on the general web concepts. And then you see that kind of sync, star, and yield thing. If you're not familiar, this is a Dart syntax that you can use to kind of easily write a method that returns a list. So here you just say sync star, and then you can yield multiple elements. It's the same as you could just return a list as you would normally, but it gives it a little bit nicer flow and looks a bit nicer in my opinion. And yeah. And then the things that you do return here aren't columns or containers or something. Those are actually HTML elements. So we have a div, a paragraph, an image, whatever. And everything together then renders into normal HTML. So it's a pretty direct mapping. You see in your code the elements. And again, Jaspr doesn't try to be as Flutter in every single way. It just takes a concept that makes sense from Flutter and tries to be familiar for that. But it also takes its own concept like HTML elements. It doesn't try to kind of abstract those away. I'm sure in the future there will be something like UI libraries, which has components that are pre-styled, that are easier to use, where you don't necessarily use HTML elements itself. But one that doesn't exist yet, it's just a lot of work. And two, you still have kind of the underlying core building blocks are HTML elements. Now, this is a bit short. What Jaspr actually does is it creates the browser instructions that result in the HTML. Because when you're like inside the browser, you have all these API to create elements, update elements, whatever. And those will then actually create what is called the DOM, which is kind of the browser's internal representation of your HTML tree. And the step of kind of creating these making these DOM instructions, Jaspr does very efficiently with all the kind of, as Flutter does it, trying to, between two build steps, trying to figure out what changed and only updating these elements that actually changed and doing that in the most efficient way possible so that your site is fast. To see kind of from a structural perspective how that works, let's first look at Flutter's rendering system again. I'm sure you're familiar. We have the widget tree, we have the element tree, we have the render object tree. Now, Jaspr's rendering system is completely different to that. We have the component tree, we have the element tree, and we have the DOM node tree. So super different, right? Like component is actually just a different name. And then DOM node, it doesn't have render objects. It uses the browser internal DOM nodes. Well, and if you now think I just copied it over because it's so super similar, you're actually right. This was kind of the first step of creating Jaspr. Is I took the Flutter framework, like the core framework code, which is open source, and copied it over, did some renaming, widget to component, and then went from there. And I think this is super great. It's a win for me because it saves me a lot of time. But it's also a win for you because you get now kind of this super familiar structure with widgets and elements, and you know how that works, and like doing state management and stuff is pretty much all the same between Flutter and Jaspr. And yeah. So in preparation of this talk, I went back and kind of diffed Jaspr and Flutter's implementation to just see how much it differs now, because obviously I did a lot of modifications in the last 2 years. And I was surprised, actually, it's still kind of about half of the code is still the same, if you ignore the renaming from widget to component, that is. Which I was super excited about, that it's still so close. And actually reading through it, I saw a lot of stuff that I still could improve, and where kind of the Flutter framework in the last 2 years improved. And since Jaspr isn't a fork, but I just copied it at one point in time, I could now go back probably and also improve a lot of things in that widget element system. Now, let's dive a bit deeper and look at how rendering actually worked. As I said in the beginning, I had no clue when I started. I just looked at it and tried to figure out how it worked, tried to copy stuff over, see what sticks. So I want to share a bit of also what I learned. And the first thing, obviously, I want to come back to is multiple children. Having multiple children for each element. In Flutter, we can also have multiple children, but those are always limited to a specific widget that is also a kind of a render object. So like column or row are the kind of typical ones. They are themselves kind of a render object, and any other like stateless, stateful widget only has one child. Which means the trees that result out of those are pretty much all the same shape. So there are, especially between element and render tree, there are different numbers of elements, but the shape is always the same. Like the amount of branches you have is always the same. Because there are two invariants that I think like the Flutter team did a very good choice here. The one is that only render objects can, like render object elements can have children. And the second one is that all leaf node, all the bottom ones, are also render objects, so you don't like end with a stateful widget or something. And this is what creates these like very strict trees that are the same shape and also easy to deal with, kind of. When I said like, okay, I want to have multiple children everywhere, I wasn't aware that I totally fucked myself over, and it's got super complicated. Because now everything can have multiple children. The tree can have any size, any shape and size it wants. And also kind of the leaf elements could be just floating stateless widgets or stateless components. You could make a stateless component and just return no children. So dealing with all those complexity, I was at first very overwhelmed. I think by now I did like 4 or 5 reworks of the whole internal structure, because yeah, as I said, those both invariants don't apply anymore. And yes, so this made it very complex to work with. And in the Flutter framework, you have a lot of like links between nodes to make it more efficient to deal with the whole tree structure. In Jaspr, this just blew up. Like I have probably 6 times the size of like little implementation details that try to make the whole implementation efficient. Because in the end, you have to walk the tree up and down all the time you want to modify something to see where you want to attach your nodes. Yeah. Looking at it from different perspective, not from the tree structure, but maybe from the rendering pipeline. These are, I also took this from the documentation. These are the 7, I think it's 7 layers that the rendering system at Flutter has. When we apply that to the widget element render objects, the widget sits at the first 3 kind of. It goes to the build layer where you build the widget. Then you have the element. I find it hard to put in a single layer because actually the render object then sits in the layout and paint layers. where you have in the render object actually your implementation for the layout method and the paint method that either you implement or is already implemented by the Flutter framework, and the element just kind of links between those. And the element controls the render object and updates and values, but the render object is the one that actually implements the layout and the paint function. And then everything below that is pretty much skier or impeller and the GPU, stuff we don't usually deal with as Flutter developers. For Jaspr, the component, again, just renamed widget, so it is the same layer. The element also has a pretty much similar purpose. But everything below the build layer, actually, is the browser. So the browser has its own layout system, its own painting system, and everything below that. So, and the DOM nodes are kind of the render objects of the browser. So in Jaspr's case, it has a render object class, but this one doesn't implement its own kind of layout or painting algorithm. It just sits in between element and DOM node to interface and control the DOM nodes that the browser has. How that looks in code is you have the DOM render object. It has the update element method. Similarly, how you would update your render object whenever the widget changes. And there you just see, like, it has a node. This one is the browser one. And then it just updates it. So it's either, like, it's create one if it doesn't exist yet, and then it updates the attributes depending on, what classes or styles you set. So it doesn't implement it itself. It's just kind of an interface there. So with all that, Jaspr uses a lot of kind of structure and system for what the browser already have. So it can also kind of leverage the performance of the browser. I took some benchmarks. You can see it. There's like a website linked in the documentation. And I compared it to React and Angular, which are kind of the big established JavaScript frameworks there are. By now, after a lot of improving and optimization, obviously, Jaspr doesn't compare so bad. So it's about 20% slower, or I like to say 80% as fast. It sounds nicer. So it's kind of up there. Like, I would even say in normal, like if you have a normal website, you won't really notice it. These are like millisecond differences. But the interesting part, if you break it down, so you can, if you do benchmarks in the browser, there's a nice tool. You can break it down into how much time is spent on rendering and how much time is spent on your code execution, which is JavaScript. So just looking at the rendering part, Jaspr is actually faster. It's a super tiny margin. It's like half a millisecond, so probably if you run the benchmark multiple times, you get different results. But it's actually, so the kind of just the rendering part is the same. And this just shows that when you do all the optimizations that you only update the elements that you need to, it doesn't matter, like the framework doesn't matter. There's kind of a limit on how fast you get, which is limited by the browser itself. And Jaspr kind of is there. What makes it today slower is JavaScript. So it just does, generally, it does a lot more than these other frameworks. Mostly because, so one part is the Dart2JS compilation, which just is inherently more complex and just adds more function calls and more variables and whatever, and each of those take a tiny bit of performance hit. The other thing is that with the widget and element and render system, Jaspr does, I would even say, more than is needed to. So because it has like this updating mechanism to see, kind of surgically update the elements that need to be. That happens once between widget and element layer, as in Flutter, but it also happens kind of between the render object and the DOM node interfaces. So it actually happens twice. That is at least my explanation for why it is so high. And I'm very curious to see when WASM comes out for Dart Web, how this could potentially improve a lot and then make the overall performance again better. Just as a side note, WASM, you can use WASM already for Flutter Web, but it's not like the tools aren't there for if you just do Dart web, which Jaspr depends on or is built upon. But there's like open issues and open pull requests. The Dart team is working on that, so I hope to get it very soon. And then see how it goes. So everything we talked about so far has been just kind of comparing Flutter and Jaspr, which also means it's everything that Flutter can do compared with kind of the way Jaspr does these things. But Jaspr can actually do a lot more than Flutter can do and goes beyond Flutter because it is a normal web framework in the sense that it builds normal websites. And one of those things that Flutter can't do that Jaspr can do is server-side rendering. So you can render your site, your page, already at the server. And I want to dive a bit into these things because I think they are interesting to look at, especially for Flutter developers. We might not be super familiar with them. And yeah, so as I said, everything so far has been rendering on the client, which means we kind of download our code in the browser, execute it, and yeah, use the browser APIs to render our elements. But with Jaspr, we can use the same component and render it on the server, which means here rendering doesn't mean painting anything. Rendering just means outputting HTML markup as a string, and this string is then kind of sent to the browser when it requests a page. Or it's stored in an HTML file. We can, whatever you want. But the important part is you can use the same component both on the server and on the client, and depending where you use it, it's kind of a different rendering. I'm always calling server-side rendering, I'm more favorable to calling it pre-rendering, because it says one important aspect of it. These two renderings aren't separated. They are very strictly, like in a time manner, very strictly dependent. You only first have the server-side rendering, and then you have the client-side rendering. It's always in that order. So I actually think looking at it in a kind of in a timeline manner makes way more sense. So let's do that. Let's first look at just client-side rendering, how a Flutter web app would work if you don't use server-side rendering at all. You have your page request, so when the user starts to types in URL and loads your page, you immediately download kind of an empty page. That's your index HTML file. You maybe have a few like heads, like a metadata or something, but you don't have anything in the body. There's nothing there yet. It's kind of a blank page. Then you download your client-side code, so your Dart compiled to JavaScript, and then you do the initial rendering of your app by calling the run app function. And this one then just kind of builds your whole page layout. But in most cases, this looks something like this, because you don't have any data there. You may have like your layout code, but let's say we're building a blog site like Medium or personal blog. You want to see all your articles there. You don't have the data yet. What you're doing is rendering a shell. Maybe you have some loading indicators. You're doing then an API request to your backend. This one. You fetch the articles, in our case, and then you can render again, and then you have actually the content that you can render. And I put some flags here. So the first thing that we say when we have our initial rendering of the page that has some meaning to the user, so it has some layout, but there isn't any content yet. It's called first meaningful paint. And then when we actually have our content is the first contentful paint. And the thing we try to optimize always when you're loading a website is that first contentful paint. So the first time, or the time, how long it takes for the user to first see some meaningful content, and you want to optimize that. Especially if you're dealing with users like on mobile phones or in mobile networks that maybe have a slower internet connection. You don't want that to take like 2, 5, or even 10 seconds. Ideally in a couple of 100 milliseconds as it's there. So let's try to optimize that now with server-side rendering. What we can do is move the rendering of our website shell. Oh, yes. Move that to the server and do that at the beginning. That moves our first meaningful paint immediately after the user downloads kind of the initial HTML. It's still our loading shell or the page without much content, but the user sees at least something a lot quicker. And then we do the rendering again, and this is now called hydration. Let's first look at the server-side code. So you also have the run app function on the server, but it's under a special import. And this one kind of spins up an HTTP server in Jaspr and then serves your component. There's also the special document component. This gives you kind of the basic structure of HTML, head, body, these kind of standard HTML elements, and you can also set some meta tags. And then we provide our app component that's then rendered inside the body. And then on the client, the code doesn't change. What changes is kind of the internal handling of that code, because now we already have our layout in the HTML. We don't need to rebuild it or completely recreate it. That's where the term hydration is kind of a standard term in web development. It means you have your kind of dry HTML that does nothing except existing, and you hydrate it with things like event listeners. You attach your event listeners, you make it interactive, you make it maybe move, add some animations, whatever, and kind of do the initial client-side rendering to hydrate your existing HTML markup. So we have now both rendering on the server and on the client. So what Jaspr actually does, it has two different implementations for its render object. It has a DOM render object, which I showed before, which happens on the client. And then it has a markup render object, which happens on the server. And those two are kind of split using Dart conditional imports. This is a feature of Dart that you can import different libraries depending on which environment you're in. So if you're in the browser, JavaScript environment, you can import one file. And on like a Dart.io or a VM platform, you can implement another file. And Jaspr does this to kind of switch out the implementations of the render object, depending on if it's server or client. Now going back to our nice timeline, while we moved our first meaningful paint a lot more to the beginning, and it's a lot faster now, actually our first contentful paint is a bit more behind, because we have to do the hydration as a kind of additional step now. And the other thing that this isn't really optimized, because we are going from the server to the client, loading some JavaScript, then going back to the server, loading some data, and going again back to the client. So there's a lot of going back and forth here. So that's why that's the dumb way. Don't do that. The smart way is to push our fetch articles or any database call or any other async work you need to do on the server. You actually can push that before you do the server-side rendering. So you already do all the work that you need to do on the server initially when the browser requests when the user requests a page, and then directly when it's downloaded, it's already the first contentful paint, because you already have all your data. You can fill it in your website, you can pre-render it, everything together on the server, and you have the first contentful paint already super early, and that's amazing. Now, in order to do that, we need to do some async work, database call, whatever. But if you remember from Flutter, all our build methods are synchronous. So how can we do any asynchronous work kind of in the build method? Because we can't, in Flutter you would kind of first render a loading spinner, then do the HTTP request, then do set state, maybe a state management, and then update the thing again. But on the server, we only render once. We render once and then send to the client. So everything we need to do and like async work needs to happen during that first render. So we actually need to make that first render, or Jaspr needed to make that first render asynchronous. And the way this works now, yes, that's a smart way. The way this works is Jaspr has a special component, which is called async stateless component, which allows you to write a async build method. This one, again, uses some fancy syntax, which is now async star. It's kind of the same as with the iterables before, but now it returns a stream. Just think of it as you can return multiple components, but you can also do awaits right in the build method. And this is only safe because it's done on the server. It's only rendering once. You don't have to think about, oh no, it's now calling this fetch function again and again during building and whatsoever. This doesn't happen on the server because it's only executed once. So it's safe to do. In order to implement this, 2 steps. First, the element, so the internal implementation of how the structure works, actually allows for async or for returning futures in the perform rebuild method. And then, yeah, it calls the build method of the component and awaits it, and then you have your children. This also means that the build owner, which is a class in the Flutter framework and also in Jaspr, that kind of controls all the rebuilding of the element. And the build owner also needed adjusting, which I took the same concept as with the multiple render objects on different platforms, where on the server there's a special implementation called async build owner, which can handle all these asynchronicity of the different elements. So I want to go through on one example how that works. You have the root component, you're building your root component. This one returns 2 children in the build method. You start again building the first child. This is now building, and this is now attaching. Attaching means, so building is the step where you go from widget to element. Attaching is the step where you go from element to render object. And you have to wait for the attachment. You can't do it before every other previous sibling of yours is already built and attached. So that's very important kind of a thing we need to adjust here. So now let's say this element, the right one, is now asynchronous and it's doing some operation. The only thing we can do now is wait. We can't do anything else here. So we have to wait until the asynchronous build method is done. This now maybe returns 2 more children. And when we go continue, and we go to another child that is now asynchronous. Here in that tree, let's say we're waiting for some more information from a database. We can't go any further in that branch. However, now we can go any further in a different branch because the right child is kind of independent of the left child. So what the async build owner does, it kind of manages if you have multiple children or multiple branches of your widget tree, you can continue actually in a different branch, or it will continue in a different branch while the other asynchronous components are still waiting. So we can continue here, building that out, attaching it, so going back up because child attaches before parent. And now we need to wait because the right one can't attach before the left one is attached. So now we have to wait again. And when it is completed, we go all up again and attach everything, and then everything is done. So what that shows is it has an implementation to wait for asynchronicity, any async data process that you want. But it will do that in a way that it doesn't block kind of independent branches of your components. So you can have kind of a list. If you have a list of many children and each child of that is asynchronous, those all operations will probably run in parallel. So just to improve the performance of that. Now, this is already pretty optimized, but there's still one thing we can do. The main blocker here, or the one that takes time, is downloading all the client-side code. Because right now we are the full app, and if you have a large site that can be like really large, you're rendering everything on the server, then compiling everything to JavaScript, sending everything to the client, and rendering everything on the client. So probably there's a lot of code in there. And if you're building kind of websites in a traditional sense that has a mostly static layout, like a blog site, you have a list of your articles, or in a blog you have all the content of your article. This probably doesn't change much. There may be a few interactive bits in there, interactive components, like a like button, a comment section. Those, of course, need interactivity and click events and all that stuff. But you don't need everything on the client. So what we are trying to do is shorten the amount of code that is sent to the client, and thereby reducing the load time for that. So reducing our JavaScript bundle, which makes the downloading and also the hydration faster. We do that, or we start right now. We have it everything like this. The tree is the same on both sides, server and client. Everything is sent to the client and rendered there. What we can do with Jaspr instead on the client is, yes, this, let's say this doesn't change and is never gonna modify it, kind of. We can move those two bottom ones up and only render those on the client. And those are now kind of separate trees with two root objects. And this enables us to just ship less code and be faster. In Jaspr, the only thing you have to do that is annotate your component with add client. And then Jaspr will do all the magic in kind of separating those out from your app and sending those to the client, hydrating them. So let's see how that works. First, you have your annotated component, and you can annotate pretty much any component you want. Then Jaspr will kind of generate an entry point for that. So before we had like our own web/main.dart. Now we don't need that anymore because Jaspr will generate one for each client component and call the run client function, which is a different version of the run app function, for you. What it also does is when you render out this component, let's say you render a button, it will go in after the kind of server-side rendering is almost completed. It will go in and add a HTML marker. This is just kind of an HTML comment. And it kind of marks the location of your component in your rendered HTML output. There's still some seeds in the front if you want. And with those two things, the kind of generated entry point that gets also compiled to JavaScript and your markup that is kind of also marked by Jaspr, you can use, or it uses an implementation that when you first do the hydration, so you do the first rendering on the client, Jaspr will check and look for these markers and then attach your component at that place in the HTML tree or the HTML markup. And that way it's super convenient to just annotate a component. So that's all you have to do. The rest is done by Jaspr. You just annotate it, use it as normally in your server-side rendering, and it will automatically kind of be attached on the client. Now, there are a few more kind of tricks these components have. One thing are parameters. So as any component, you can this component can take parameters. If you take parameters, or if you add parameters to that component, Jaspr will actually do some serialization magic to serialize them on the server, send them with the HTML markup to the client, deserialize them, and then you have them on the client. So client components are actually also a super great way to send data from the server to the client. For example, again, if you have the article list, you could actually send your whole article JSON structure or whatever you have and just pass it in as a parameter and it will automatically be sent to the client. All right, so we had a very long journey for all the people that just came. We had the first contentful paint at the very right side, and now we step by step optimize it to go to the left, and we have a super awesome fast loading page with Jaspr now. But there's still one thing we can do. For our use case, we have a list of articles we want to show in our blog site. These articles probably don't change much. So it's actually quite inefficient to, for every single user, when the user wants to load your page, to redo the database query. like for every time. Imagine 1,000 users request your page in an hour. You have to do 1,000 database queries. Why would you do that? It's super inefficient. So for data that doesn't kind of depend on the specific user's request, so data that doesn't change much, that's kind of just there and you want it once, why don't we just move all the database fetching stuff before the request? So let's do that. We move it before. What is before? Before is compilation. So when you compile your website, when you build it, we could already do the fetching and doing compilation do also the first initial render. This means it also pushes all the rest to the start. Yes. And now our first contentful page paint is even more optimized. So a few hundred milliseconds maximum. So it's immediately there. And what we just did is kind of reinvent static site generation. This is static site generation as you would do it. You already generate your pages, your website at compile time, which outputs a normal website. You don't even need to have a server running, but you still have kind of all your components and all your app in Jaspr and in Dart. So that's kind of the third way that you can use Jaspr. The first one was just client-side. The second one was normal server-side rendering. And the third one is static site generation. And also, if you might have guessed now, we just moved some boxes here around. The implementation didn't change much. So the code you write in server mode or in static mode is actually super similar. Like there is like 1% different, or maybe you have to adjust some tiny bits, but it's actually super convenient and easy to switch between server and static mode because it's the concept is the same, it's just doing the rendering at a different time. How it does that, as another small look inside, looking inside the CLI tool, it's also built in Dart. So what it does in static mode, if you run Jaspr build, is just for every route there is, just do an HTTP request to the running server. So it just starts the server locally, normally, as you would doing like when you start the development server. And it just does HTTP requests to it, downloads all the HTML that was pre-rendered, and saves it in an HTML file. And that's pretty much all there is to static site generation. And with that, we come a bit to the end of my talk. There's, of course, so much more to discover and so much more I would love to tell you. For example, Flutter embedding. You can embed Flutter apps into a Jaspr site. Or you can actually use certain Flutter plugins with Jaspr without having a Flutter app running, but you can still use those plugins. And there's a lot more to discover. Please come talk to me if you're interested in any of this stuff. You can also, of course, check out our documentation. Maybe I will be here next year to talk about some of those things, maybe somewhere else. And yeah, last thing for me to say is please try it out. See for yourself how Jaspr can make building websites suck less and be actually a very cool experience for Dart and Flutter developers. Thanks. Do we have questions or?
No time for questions.
All right.
Sorry. Yes, so thank you very much, Kilian. If you want to ask more questions, he will be around. He's online as well, so you can write to him at any point. And if anyone who was here are interested in listening to Wasm by Hanan, he's upstairs. Otherwise, I would like to give the stage to Majid, talking about design principles. Thank you. Give him a hand.
This talk, I know that we're competing with another greatest speaker upstairs, and also, can you turn down my microphone a bit, because my voice is loud enough? Yeah, sounds good. Sorry, I try to keep my voice a bit lower. And also, we are before the lunch, and thank you for, when I looked back, I was sitting there and suddenly looked back and said, wow, the room is full. I was a little bit nervous, to be honest, because I thought that probably I will leave the room for the other speakers because no one is going to be here for me. So, but I appreciate that. We're going to talk about design patterns. Of course, this is a very interesting topic because when someone is talking about this, that means that person is expert and probably very professional, a couple of 100 years of probably, because often we looked at these terms in software engineering a bit overutilized, and also the other way around, sometimes underutilized. So we want to figure out, like, after this talk, hopefully today, that why you need to know design patterns. And what does actually mean? Do you really need to go and open the Gang of Four book, a thick book like this, and read like 30 years old textbook to just figure out 25 design patterns, and then tomorrow go to work and say, hey, I know today I want to actually select this one and I'm going to implement it today. And if that happens, please call your boss and say, hey, I'm sick, I don't want to come to office. Because that's not the way design pattern works. So these are the things that I'm going to talk about. I don't even see it myself. But you see right now, I'm going to stand here to see my screen. So a little bit talking about design patterns and why we need to go through it. And then I picked 5 design patterns. I cannot talk about 25 or 30 these days, even more design patterns in Flutter, of course, or any programming languages, because I have only 35 minutes, right? So I just want to talk a bit fast. I'm not sharing my screen. Ah, fantastic. But how can I do that? Ah, Greg's problem. Sounds good. Let me see. Sorry for... At least I'm showing the nice little dash, right? Yes. So I need to do this one more time. Open this. And will it come right now? There you go. My beautiful slides. And start presenting. There you go. Okay, I'm not going to start from the beginning, but I want to tell you that for some reason, my creative mind told me that I need to be very creative for the slides. That's why I picked some kind of template that I don't know why. I just thought that's because it's so creative. Anyway, we get into it. And we're going to talk about 5 design patterns. I will talk pretty speedy, but don't worry. You'll get the slides, you'll get the sample codes, everything. Don't worry about that at the end of the presentation. But my main point is to just show you how, even if you don't know design patterns, today in your Flutter application, you're using some of these patterns without you noticing that. And how you can optimize for utilizing these design patterns a bit better. If you know the patterns itself, to be a little bit more inspired and then use that. A couple of these design patterns actually very specific to Flutter, maybe like creating a closed hierarchy with sealed. This is not part of like necessarily the original book, but this is something that we use, or we can use in Flutter as well. But let's get into it. So for those who don't know me, my name is Majid. I am one of the Flutter GDs and also a community lead, as well as a lot of leaders here. So I also wrote a book called Flutter Engineering. When I was drafting the book, I was like thinking about these design patterns. Where can I put this in my book? And how should I bring it up? Because a lot of these concepts about design patterns are like very engineering-based and sometimes hard to understand. And even hard to apply to what you're doing, because these were kind of created way back for object-oriented, programming languages and so on and so forth. So that today, we need to a little bit modernize it and maybe even apply it to our Flutter application. I want to give a shout out to Mangridas. I don't know if he's here or not, but he is in the conference. He created flutterdesignpatterns.com. It's actually consists of all of the design patterns from the Gang of Four. So you can actually take a look at the website. Great source, so much into details, UMLs, if you are a very big fan of those kind of things. He reviewed my chapter, and I can say that some of these codes are reviewed by expert. But design patterns. The thing is that design patterns are not the way that you exactly kind of solve the problem. That's the misunderstanding when it comes to design patterns. We think that, oh, if I know right now singleton, for example, the problem is solved. That's not the case. I think we should be clear here why we need to learn design patterns. What it does is actually shows how, in which way you can solve the problem. And this is very important because it means that design patterns is not here just to help you to design, but it's also here, it's actually here to help you to communicate better. It's a communication tools. So in an original, for example, book, well, there is, this is like very traditional, right? So 3 different categories, and each of these categories are actually dealing with something with the object, right? But what I'm going to say today is not just going through that. I'm just going to convey another message today, hopefully. And that's, the truth is that the design pattern is actually a shared language that you need to know. Just like Dart, that you know some of them, and you just talk in your team, and everyone understands. And if you just go through these design patterns and get yourself familiar, not memorize it, not just have it as a Bible and just implement it every day in your code, it means that you're going to have a common language in your team. When a problem comes, you may have some idea how to solve it, and then you can say, hey, this is actually similar to singleton. Maybe we should apply that. So, but the good thing, the interesting thing here is that you know all of these design patterns, 25, 30, whatever, that looks like a hammer. If you know all of them, tomorrow go to work and say, OK, today I'm going to choose this one to implement. That's like a hammer, and then you look at everywhere and you see nails. You just want to just crush it. Don't be that hammer. That's what I'm going to say. So we need to find out how to solve the problems, and these are the tools in our tool set. Just like any person who is going to work with a screwdriver, if you have sometimes a manual one, well, it solves one problem, but if you have the electric one, it solves a different problem. So that's why I wanted to bring you to 5 of these design patterns to see how we're solving the problems in Flutter application with this, and probably also already doing that as well. Initially, I planned to actually live code, and I practiced once, and I realized it's going to take time because I only have 35 minutes, and it's hard to write Flutter codes because it's a lot of code from time to time, although I have Copilot and it can help me, but you never know because Copilot is working well, but sometimes also not working, right? So then I thought that maybe I should put all of the code into slides. At least I can convey my message. But Don't worry if you can't read the code. Don't worry about any of this. You get the slides. You go through it one by one, and even go through the examples code later after the talk. But let's get to one of these, factory method. This is one of the design patterns that you already are using that I bet all of you in Flutter application. So you can imagine of this pattern as solving a problem that is going to help you to create subclasses, which is going to make sure that let's put it this way. Let's give you an example. Imagine now you have a factory, and there are different ways to ship your product, whether with ships, whether with airplanes or trucks, and so on and so forth. So this way that you can define to reach to your goal is the way that we call it factory method. It's just a live examples. Let's put it into code, and I explain a bit more what it does. Technically, you're going to have an abstract, let's say, class that every other subtypes is going to implement that. And you're going to have a method which is going to create this. All right? But why? Then based on implementation of this abstract, or extending or implementing this abstract, you're going to have this create method that is going to specifically for each of these factory methods abstract away the implementation. That's one of the things that we're going to solve. We're going to abstract away using this implementation without touching them directly. All right? So then, I bet you're using this example in your application already, where you kind of have these kind of elf and if, and you go through each of these factories. And if you look at this by now, the factories are not doing anything until you actually call this explicit create widget. And that's where you are actually building your widget. So then, why you think this is pointless probably, or we are already using that? It's going to get interesting when you actually apply that with a default method. Look at this example right now. Let's say I'm going to create a widget creator. So I have my factory method to be implemented by subclasses here to implement the concurrent examples. All right, sounds good. Then I'm going to have a default method which is going to build my widget even by creating those subclasses already here. All right, this is getting a little bit more interesting. So when is going to be useful? What kind of problem we're solving here in this case? So imagine a great example from Flutter, the Design Patterns website by Mangridas. I actually want to repeat that because it's a great example for this pattern. Imagine how many of you are building like custom dialogue to show in different platforms differently based on the UIs? I bet all of you are doing that, right? So, or at least having some kind of widget that needs to be shown in different platforms differently. So this custom dialog is going to have a show method, which is going to actually create the subtype and then show that. All right, why this is going to be useful? Then you're going to have your implementation, like Android dialog or iOS, for example, in this case, using Cupertino. When you are going to use that, you just need to call show method, and it's going to just build everything for you. So combining this with a default method is going to be a powerful tool under your control. Let's take into another example right now. Another pattern. Decorator. So all of us are wearing the clothes when we're going out, right? But depends on the day, you may have a different decorate on yourself. Like today is rainy, I'm going to have a rain jacket. Tomorrow is hot, I'm going to have T-shirt, and so on and so forth. So the decorator purpose is to help you to kind of have a decorated widget and then applying different filter to it, either by sequence or differently. So an example here is a text. So typically what you do here, you're going to have an abstract class that all the subtypes of the decorated widgets are going to implement that. Which in this case, I just have a very fairly simple example. Imagine this is just going to render a text, a simple text. Okay? So now I want to, in different scenarios in my application, apply different filters to this text. Sometimes having a border, sometimes having a padding, and sometimes a background. Or maybe sometimes all of them together. So what I can do is that I can actually create a decorator right now. It's an abstract that is just going to define the decorator class for me. So it just accepts that decorated widget. Okay? And then it applies the filter that you want to apply to this widget. For example, in this case, I'm going to add a border. In this case, I'm going to add a padding. And in this case, I have another class that it says background text, just adding a background. So I'm trying to abstract or make a separation concern. So my simple widget doesn't deal with any of these filters anymore. Actually, I put it into the subclasses so that I can deal with it separately. So what happens is that right now, I can go ahead and use my base component or base widget, in this case, my simple text, and then try to apply or pass it down to different filters. Now give me a border or give me a little bit padding, and then at the end, just build what you want. This looks a bit not Flutterish, right? So we can make it a bit better. In fact, I was playing around in a project and I came up with the chain decorators. It's also, I think, in a lot of design patterns by other softwares. What we can do, instead of having the decorators separately, we can actually create a chain text decorator here. What it does, it accepts the base component, whatever component that, or widget, sorry, when I say component, I mean widget. It accepts the widget. You go and show that widget if there is no filter or there is no decorators, or I also accept the decorators as a list of decorators. And in the build method, we're just going to have either the base component or just iterate over that and apply the filter sequentially. OK, that's getting a bit more interesting. So let's see how it's going to look like in the code. Now let's say I'm going to have a text widget that I'm going to apply different filters. And different filters are already implemented separately. I deal with that in the different classes. So I'm going to go and pass my simple widget, and then I pass my array of filters, or decorators in this case. Please add padding, border, and background. And when I build that, this is what you get. Now you can go ahead, after you get the code, and play around. Just remove one, add one more, or remove all the arrays, and you see how you're making this more flexible by doing the chain decorators. Everyone with me? Sounds good. This one is the most exciting one and also my favorite. Execute around method pattern. I bet all of you have dealt with this problem in any application so far. But let's see how this pattern is going to solve your problem in Flutter. what it says, the pattern, it says in any application, you have some kind of operation that usually needs some kind of preparation, and then execution, and some kind of cleanup afterwards. An example, network requests. Maybe loading in Flutter, and then execute, show the data, and then clean up whatever it is. Or maybe another example could be database transaction. You want to open the database connection, make the transaction, close the database transaction. Might not be very, very familiar with you in Flutter, because we don't really do that much database directly, except if you use SQLite or something like that. But in backend, this is quite common. So let's take an example. I'm going to create a loading manager, the loading concept that I explained. So which is just going to accept a context, that's it. So why I do that? Because then I can create a method here that is going to execute around the operation. I pass my action, so then what it does, it says, hey, in a try catch, just go ahead and show first indicator, a loading indicator. Sounds good. Do the action, whatever I'm passing you. That's a function. We can do that in Flutter. That's a nice thing about Dart. And then at the end, finally clean it up. So these are the implementation of the show indicator and hide indicator. So like technically what you do in Flutter, your navigator pop or for dialog or showing a serial progress indicator. So let's see how we can use it now. So in my application right now, when I click on a button, I want to make a network request right now, but I want to show a loading first, and then whatever the result is, and then make sure that I'm also printing out some kind of log. And that's exactly what I'm going to do here. I have my loading manager right now, which is going to just call the execute around and pass my network or whatever action that I have. And when I click on the button right now, I hope it's visible, but you see the loadings first, and it just does the print after the operation is done. This is quite useful. You can think about now many use cases, many problems in your application that you can use this pattern. OK. Let's go through another one, strategy pattern. In fact, the one that I'm going to show you is going to be a lightweight strategy pattern. So the strategy patterns tells us, like, deal with the context strategy rather than the direct implementation. What does it mean? Like, please talk to me in English. It means, let's imagine you have an example. You have payment method. In your application, you just want to click a button, pay. You don't care at the end, the selection is credit card, or it's PayPal, or it's X or Y. So this is a context. You just want to say pay. But the strategy could be different. It could be credit card. It could be something else, right? So you abstract away again. One of the things you do here is not dealing with the concurrent class of implementation directly in your code, but rather working with the context, which just doesn't know anything about the implementation and how even it's implemented. It doesn't care. It just call a pay method, for example. Let me just give you an example. You define a strategy here, payment strategy. And it's going to be an abstract class where has the payment. And it just needs some kind of amount at the end to just execute that, right? But in your company right now, you have maybe 3 different payment methods. You have credit card, which you can override the pay right now. You can just completely implement your pay implementation. or you have PayPal, or maybe now they're asking you to add also crypto. The good thing about this strategy is that because the implementation is abstracted away from the context, you can do that anytime and just go ahead and add it to the list of approved payment. Let's take a look at that. Like how? So to use this pattern, you need a context, strategy context, where technically what it does, it's just going to set the strategy. There is a reference to the strategy that you want to call the pay after all. So you have the execute, let's say, payment, and what it does is just, based on the strategy that is selected, just pay. From now on in your application, you're going to go and use the payment context. None of those implementation matters. Those are abstracted away. You can deal with it differently. So imagine now I'm going to have a strategy. This is obviously a pseudocode, right? You're not going to do that directly in your widget. Probably a better code organization. But imagine this is going to be my strategies, list of strategies, credit card or whatever. They're just going to instantiate create an instance of my implementation. Doesn't do anything else. And when it comes to the execution, well, first you can go ahead and set the strategy, and we're going to see the implementation quickly. And then when I say I want to pay right now, I'm just going to pay. Let's take a look at the implementation. Let's say in my application, even in this, I think it's visible that you see there is 3 buttons, which is going to set the strategy. I'm going to pay with credit card. OK, check. So my context strategy right now is set. And then at the end, I'm just going to click on pay, which, if I go back, the pay is going to say payment at context.execute payment, right? Let's take a look at that. I think, I don't know if how visible is that, but I hope you see that. I'm changing, and then I click, and then it says, oh, you are paying with crypto, credit card, or whatever. Good? Can we say yes? Yes. Can we say louder? Yes. And louder? Yes. Fantastic. Some people were sleeping. I don't know whether I'm speaking too low or too boring. All right, let's get to another one. This one is actually interesting because it's dealing with the new modifiers of the classes in Dart. How many of you have checked the class modifiers table and what they do in Dart, the new one? Oh, perfect, perfect. That's what I want, like almost 5 people. So, yes, if you go and take a look, it's so many modifiers. I get you. But there is a reason they are there, believe me. It's also hard to remember them. And I don't think even Flutter team and Dart team knows what I think there is a reference they always check. But it's important that we understand what kind of problem they're solving. And among them, this sealed class is actually a funny story. Like Flutter community were nagging about not having the sealed class. We don't have a sealed class in Dart. And then it came and no one checked. But it is here. It's a sealed class right now. What it does, it helps you to, it actually prevents a class from being constructed directly, extended directly, or implemented, or outside of their own library. It's super useful. Like imagine you are in your team, you're developing some kind of library that you want to share between your teams, but you don't want anyone to mess up with the class that you're sharing with them. That cannot be extended. And another thing is actually interesting about the sealed class is that compiler knows about all the subtypes that is implemented. It's, in other words, it is statically ensured the exhaustiveness. Okay. Let's see. An example would be, imagine you are creating some kind of network state to just apply to your network requests. You have a network state that's going to be a sealed class, and then you're going to define in your library, you're going to define a loading state maybe, or a success class, or an error, and an empty one, like 4 different states. So I have 4 different subtypes of my sealed class. Let's see what happens to this right now. We're solving a problem here, is that when, after you are implementing this, let's say you have a network request, and this network request is just going to return different states based on whatever it comes, right? So when you are going to use this class, this state, there is no way that you just implement one of the states with the switch, let's say if you use it in this scenario. Why? Because compiling is saying, let's say in this case I actually removed one of the states, one of the class. Compiling is saying, hey, we found 4 different subtypes, but you're just implementing 3 of them. So 1 is missing, and that's this one. So there's no way that you can get around with this problem. So you have a problem right now. You want to make sure everyone is using your sealed class, are also implementing all of the subtypes correctly. So another problem that you're going to solve with this pattern. OK. 28 minutes, and that's fantastic. So these are just 5 of these examples. There are so many other of them. So like, just in my book, I think I covered 15. And still, if we look for more of these patterns in, specifically, I was looking at Flutter framework, or Flutter engine. And a lot of these patterns, without saying, oh, we are using singleton, or we are using factory, whatever, it's actually implemented there. And many of them actually implemented in a modern way, like using functions even to operate when it's necessary, not just using classes. So what I want to then say today is, use the design patterns as a communication tools, not just only a design tools, just the tools that you, OK, we're going to pick this and implement. That doesn't work. First and foremost, think about what kind of problem we're solving in our code. Because overusing design patterns, it just makes your code dirtier, harder to maintain, and even complex. If there's no need of applying design patterns, it's all good. There's no reason to apply that. Don't look for, oh, I actually find right now one thing in the code. We need to go and do this. That's not going to work. If there's no problem, that's it. Good. You're good to go. And with that said, I think I covered everything I wanted in 30 minutes. Well, that is fantastic and impressive. I know I spoke very fast, but I put the slides QR code on the screen right now. You can take your time, go through it after the presentation or later. There's also a repository called Flutter Engineering _examples, which in one of the folders you will find all of the design patterns implemented in the book. If you don't want to read the text of the book, absolutely fantastic, no problem. But you can read the code for free on GitHub. With that said, thank you very much.
Yes, thank you again, Majid. Same goes here. Majid will be here. You can talk to him at the venue.
Can we take a selfie before you go?
Yes.
I forgot. You come with me. Cheers, everyone. Come on, louder. Woo! Awesome.
And I believe at least some of you bought books as well with your tickets. I believe they are upstairs. You should be able to find them. Talk to any of the volunteers. Also, up in the main stage, I said that we would have the PowerPoint presentation or PowerPoint karaoke down here. I was totally lying. So it's upstairs in the main hall as well, or in the other room. Time for food. So please, let's all go up 2 stairs. Thank you all. Yes, so hello everyone and welcome back. Before I get started, I just want to announce that we have 2 cameras back there, so please don't stand in front of them or walk by it too many times if you don't need to. Yes, so welcome back to After Lunch, and we are actually basically on time, which is awesome, seeing as how the morning went. Okay, so first afternoon speaker down here is by Mike, talking about embedded Flutter in e-commerce. So please give it up for Mike.
Hi. So let me begin my talk with a simple question. Do you think that you can operate an e-commerce business with Flutter today? The answer to that is actually pretty simple, maybe. But the difficult question is, can you get everything done in just a few days? Because that's what we had to do, and that's what this talk is really about, because today I'm going to talk about embedded Flutter on the Raspberry Pi 5 platform and how it helped us simplify our daily e-commerce operations. And in this talk, I'm going to focus more on embedded Flutter and the Pi 5 itself, and how great of a platform it is for Flutter, and what you can build with it today on your own. A few things about me. I'm Michał. I'm a Chief Executive Officer and founder of a company called Pineboards. I bootstrapped this company and another one last year with no business background and experience, really. I'm based in Kraków, Poland. I'm 27. Before I got into the business world, I was just a regular software engineer who worked on mobile with Flutter daily, and I focused a lot on embedded in my free time. My main initial background is native iOS development, and I transitioned to Flutter in 2020, and I'm never going back. I'm also very passionate about electronics, especially the Raspberry Pi ecosystem. So, how did it all get started for me? It all started last year at FlutterCon 2023, where I presented my side project, which, using Flutter Web, allowed me to build a custom Android system image that you can use to run any Android app in your car. And after the conference, I realized that it was too good of an opportunity to pass on, so I decided to commercialize this. And in just a few months, I started selling devices that essentially bundled all the hardware together. So you had a computer, an NVMe drive, a LTE modem, CarPlay receiver, and whatever. So just take it in, plug it in, run the Flutter app in the browser, and enjoy Netflix in Drive on an autopilot drive into the sunset. Yeah, but there was one thing about this business, is that it didn't feel particularly safe, because Tesla, like all other companies, leadership can change, they can block certain things, regulatory approval can disable browser in driving, so it's not something that I really wanted to feed my family from long term. So I essentially used the money from the devices to found a second, safer business, and that's why we are here today. So, moving a few months into the future, the Raspberry Pi launched a new board, the Raspberry Pi 5. It had a faster CPU, much faster GPU that can handle 2 4K displays at the same time. And it also had more I/O, more connectivity options. It was priced slightly higher, but it was still a very good value, because for just 50 euros, you can get a 4-core ARM computer with up to 8 gigs of RAM that can run your Flutter apps without any problems. And given the extra performance, it is actually a much better platform for complex Flutter apps. And a quick side note, this is the 5th generation of the computer, but this is the first one that had a power button added on the board. I mean, I don't know why it took them 5 generations, but they finally did. So, a little question for the audience. If you ever experienced a Raspberry Pi before, what was the biggest flaw of the consumer Pi before the Pi 5 came out? Any ideas? What? Not memory issues, exactly, but storage issues, because you had essentially threads like this. Pi 4 burning through SD cards like crazy, SD cards being corrupted, so it wasn't like very production ready, the consumer Pi. You had to like get into custom boards, the compute module 4, and build your own electronics, so it was a little bit hard. But the Pi 5 changed that, because they've added PCI Express. And PCI Express allows you to basically add your PC peripherals like NVMe storage, fast network cards, SCSI controllers for servers, whatever you can think of. But there was one little problem with that. There were no PCIe expansion boards available at launch. And there was no documentation for companies like mine to start building those accessories. So it feels like they rushed the board into production without following all the steps. So we noticed a huge opportunity, and we made our own documentation. We reverse engineered the entire pinout, and it just worked. So essentially, we beat the manufacturer to the market with accessories for their own products by 7 months. And for the person who answered the question, if you ever get a Pi 5, it's an NVMe board for you. So our first 2 products launched in November last year, shortly after the Pi 5 became available on the end of October. And since our company didn't exist back then, we had to market them somehow. So we went to the community and we shipped engineering samples to all the YouTubers, press publications, wherever. And they essentially did all the marketing for us. And the moment we launched, it very quickly went viral. So we had like over 2 million combined hits on the site when it launched, and we sold everything that we have instantly. So as you can see, our timeline was moving pretty rapidly. So, and it was just me and my business partner. So our entire e-commerce took me less than a day to set up. And I'll give you a few pro tips if you ever end up going through something crazy like this. Just rely on Shopify or some other software as a service platform. Don't bother with building your e-commerce with open source solutions, because they are not actually free. You only get a very basic template, like the order processing pipeline or whatever, but you don't have invoicing, you don't have payment gateway support, you don't have DHL integrations, whatever. You would have to end up paying for all of this stuff, and it would be also lower quality. So It doesn't make sense. For international shops, Stripe is the best payment gateway that you can use. And in case you ever decide to build a Flutter app around your e-commerce store, it has a great SDK. So it's bulletproof. If you start building, you have to ship quickly and constantly iterate, because your store will never be perfect, and it doesn't have to be. Because if you have a great product, it will essentially sell itself. I mean, for the first month, we just used to have something like this, and we got thousands of orders. Just a basic render, a few lines of text, purchase button, everything. After 9 months, I've iterated over a little bit, got a better camera, started putting more focus into quality, but that wasn't necessary on day one. If we were to do it like this initially, we would just waste a month of sales, essentially. And continuing on the crazy sprint, we shipped over 4,000 boards in just 2 weeks, and it was only me and my business partner. And another tip, if you ever plan to get into e-commerce, don't do it before Christmas, because it's particularly terrible, and it makes it much more stressful and much harder. So if you can take the heat, avoid at all costs. Launch at spring or something. Those 2 weeks were one of the most intense weeks of my life. But we also made a ton of mistakes that took a while to rectify, because we didn't have any processes in place. It was all chaotic. So some people got the wrong stuff, someone ordered 1 and got 10, and it was all on us. And we were shipping to 110 countries. So if you assume that you have 600 packages on this, this is like 15 or 20,000 euros in FedEx labels. So it's like very expensive mistakes. And after that came all the paperwork. Because I made an executive decision to ship everything first so that people would get their stuff before Christmas. And now I had to issue thousands of invoices before the end of the calendar year, which was a nightmare. And since Shopify is mostly focused on international stores, there was no plug-and-play solution that handled all the edge cases well. Even for invoicing, for European Union, you have 3 edge cases. You can have packages that leave the EU, you can have retail customers with a different VAT rate for every country, and for businesses in the EU, you actually have to verify the customer data and refund the tax. And in theory, every single invoicing mistake in this flow would be a crime if the German tax office found out, for instance. So this was the situation, essentially. And this is where the technical part of the talk starts, because Flutter rescued us. And before I dive into our app, we built our internal app very quickly. And it's still running after 9 months. But I think that there are a few things that you should consider when you build an app quickly, so that you don't end up throwing it away after a few months with regret. Build using the tools you know best. Use the same architecture you would use at work, but just cut out all the excess that you don't need. And please don't put too much focus on state management. It can be simple. Just use a simple qubit or a basic view model with a few data streams, and it's more than enough. The only thing you really have to think about is separating the UI from the business logic, because if you make this mistake, you are not going to recover from it. The app is essentially is a lost cause. And one thing that I always tell people is avoid stateful widgets unless your UI components need them. You will thank me later, because it makes your app much easier to debug. So, why did we create an internal Flutter app for our company? Because, first of all, e-commerce tooling is crap. And there wasn't a single product that would get all the stuff done for us. So no matter what tools we chose, even if we chose to pay for them, we would have to use a few of them at once. One for invoicing, one for shipping, one for packing orders. So we essentially had a situation where every packing station had a 27-inch 4K monitor with 4 Chromium windows open, each running a different stupid web app that had its own issues. So it wasn't really sustainable, and it wasn't usable when you had to pack a few hundred packages every day. And another thing about third-party tools is that they don't always grow with your business. It's hard to adopt them, so you are locked into what someone thinks is right. And if something is truly yours, you can always adapt it to new processes. So, on the right, you have a very first screenshot of our app. It's just an order list. But that's all that we needed as our entry point. Shopify has a great REST API that gave us all the orders, product, and customer metadata. So essentially everything that we needed to process the order. And since we had full control over the data we got from the e-commerce solution, we could easily map it to whatever our invoicing software needed to consume. And we could also use it to pack orders as well, because the app already had all the order information. So we lost 2 Chromium windows with this basic app. And on top of that, it did all the dirty accounting logic for us. So it handled all invoicing edge cases based on the country, based on whether if it's a business or not. So it was all done automatically. I didn't even have to think about it. And after that, the invoices were dispatched automatically to our customers from the app itself. So essentially, one order took 3 or 4 clicks. Just enter the order number, create the customer in the invoicing software, create an invoice, it's done. And you also have the preview, so in the meantime, you can pack it. So it was a huge time saver for us. And this simple app, in its very first iteration, saved us hundreds of hours already. And after I managed to iron out all the issues in the accounting logic, I managed to issue thousands of invoices on the very last day of the year, just in time to close the books. And I don't think it would be possible with any third-party software that you have on the market. So we essentially tested it on production, and it went pretty well. So now we are marching into 2024. And we had a new set of problems to solve. Our app ran on macOS only. And adding new workstations was expensive, and machines were pretty much overkill, because you don't need a lot of horsepower to run an app like this. So enter embedded Flutter on the Raspberry Pi 5. I mean, it's an obvious choice for us because we make dedicated hardware for the Pi 5, and we support customers with building their own. And I think that this is the best platform for embedded Flutter today, because the Raspberry Pi is the world's most popular computer with over 60 million units sold to date. And it's also a European product, so you have great software, great support, and a great community around it. It's very cheap because you can get started for just 50 euros. And it runs Linux, so it is more than capable of running most Flutter projects. And the GPU in the new one is pretty powerful too. And it's also, in my opinion, one of the best platforms if you want to interact with external hardware, because everything is open and there are no platform restrictions. So it's much easier to deal with third-party devices instead of building on mobile or Windows or any other platform. And the best thing is that, given how popular the platform is, people are building everything with it. So, for instance, you can have an edge AI camera that is doing live image recognition. We even have 3 products with this. So you have a tensor processing unit from Google with 4 TOPS or 8, or a 13 TOPS device with an Israeli accelerator. And this running on the edge, it gives you enough power to run a simple 3-camera self-driving algorithm in the car. And this is let me remind you, this is a $50 computer. So it's amazing. A lot of companies are also building vending machines that have Raspberry Pis inside. This is a real example of something that is deployed in Poland. If you need to buy some flowers late at night because you messed up. And this thing already has a Raspberry Pi inside, but it doesn't run Flutter yet. They are using embedded Chromium with standard web technologies, and they have a dedicated local backend that interacts with all the hardware, etc. So if they chose Flutter in the first place, it would have been a much easier product to build, because you can interface with hardware directly, and it's much faster. Some people are also building 1.2 petabyte storage servers with those computers. I mean, they do it for science. And 2 weeks ago, I managed to fire up a desktop GPU on it, and we are playing and you can run 3D games on it. So with a little bit of emulation, I'm hoping we can get Crysis later this year. And the best thing for you as a software engineer is that you don't even have to think about the hardware. You can just focus on what you do best and build the software, because the platform is very mature, and in every region of the world there is a company that is authorized by Raspberry Pi to deliver you the hardware you need already. So all you need on your own is essentially a €100 dev kit that has a computer, a touch screen, and then build your kiosk, whatever, and then outsource it to someone who will build the rest. You don't have to be a master of everything. So, how do you get started with Flutter on the Pi 5? If you don't need hardware support, it's usually easier to get started with Flutter Web, because you can develop it on everything, test it everywhere, and it's fast enough that you wouldn't notice the difference for simple kiosk apps, etc. Web runs well on the latest hardware, but you are very limited in terms of hardware access. So like programmable inputs and outputs, AI on the edge, cameras, payment terminals, etc. For this stuff, you should opt for Flutter on Linux. And a lot of talks on embedded Flutter, they give you a recipe on how to set up the development environment on the Pi itself. And I think that it's a little bit hurtful for the developer, because developing software on such a slow device is not really fun. So I assume that most Flutter developers have Apple laptops that have ARM chips by now. So it's the same architecture as the Pi 5, so you can just put Ubuntu in a VM and develop there. And it wouldn't be much different than the Pi. And once you are done with the feature, just put it on your simple, basic development kit, and run it, test it. A notable mention is that there is a quick script from guys at SnapX that allows you to set up the embedded Flutter development setup pretty quickly. I linked it on the slides, and it also has all the scripts that you need for kiosk mode. So it will automatically configure your OS to boot up into your Flutter app with a single command. So it's like very, very easy to work on. Another mention is that there is a custom Flutter embedder that is called FlutterPy that achieves the same thing, but it runs the Flutter app instead of the entire desktop environment on the Pi, which is technically pretty interesting, but it's not officially supported. So it's fun to play with, but don't put it on production. You don't want a headache. And nice thing about Flutter and Friends is that tomorrow there is a workshop by guys from Snap that will teach you how to get a Pi 5 set up for development and run a simple app. That's why I decided not to waste too much time onto this, because that's just like repeating the same stuff over and over again. Okay, let's dive back to our app. External hardware access with Pi 5 is just too easy. We had another problem because our lineup has grown from 2 products to around 20. So we had a lot of packing issues with people getting wrong stuff, things getting messed up in the warehouse, etc. So what's the solution? I mean, it's a barcode scanner, essentially. You have to scan every item that you put in the box. And how can you support barcode scanning with a hardware scanner on the Pi 5 with embedded Flutter? There is 0 extra work necessary, because all those scanners, they just act as USB keyboards. So there are no drivers needed, and it works out of the box. All you have to do is just listen for the keyboard events that you get from the framework and pass them accordingly. So you can use the hardware keyboard class and just have a listener and do it in the background, and it will just work. And it took me like 1 evening to get it all implemented, so, with all of the logic. And even if you are like extra lazy, there is a package on PAP that has all the EN logic already implemented on it. And this leaves us with one last problem to solve. There's one last Chromium window left for creating shipping documentation, so like FedEx, customs, and all of the other stuff. And there was a huge problem. Initially, I thought that it didn't really make any sense, because FedEx and DHL in Europe have APIs based on SOAP. So it's XML, not REST, like ancient history. And it brought me back to corporate days. And since we are running a fully fledged Linux system, we have all of the Dockers and other things that we can just run behind our app. So I've decided to create a very simple Spring Boot-based Java app that converted the APIs from SOAP to REST, and it was running in the background all the time. And I put a link to a library that will let you do it in a few hours if you ever stumble upon a problem like this. There was a lot of custom logic involved, sadly, because for packages you need to fill out electronic customs paperwork. So that was a huge pain for us, but that is not really important. The last thing that we had to do is actually print those labels. So you have a USB printer that you just connect to a computer, and you print. And normally you would say, I need a driver that opens a USB device, starts a serial connection with the printer, and starts bouncing data back and forth to communicate, set everything up. No, no. You are running on Linux. Just use shell. It's the most basic thing you can do, and one of the advantages of an open platform. So there is no need for custom plugins. And if you can do it in the command line, you can already integrate it into your Flutter app with no issues. Let me explain quickly. First step, you get a text with the label from your API. On the slide, you have an example of how a very simple label looks like. And later, you just SSH to your Pi, connect the printer, see if it's detected. It's a single command. And on the second part of the slide, this is the entire command for printing this label with the set printer. And the step 3, integrate it into your Flutter app. There is a package that lets you run a shell process from within your existing Flutter app. It also works on macOS, so it's like chef's kiss. And you can, and it's all native .NET, no platform dependencies, etc. So essentially, integrating a printer in Flutter embedded, I would say that it's the same kind of effort as like integrating a share sheet into a native mobile app with Flutter. So it's like very, very basic 50 lines of code if you have the file. So conclusion time. Embedded Flutter is a great platform to build for, especially if you need to work with peripherals. And the barrier of entry is very low if you know basics of the operating system. Building devices for specific applications required by enterprise customers is both easy and cheap. Deployments are much easier than on mobile because you can essentially build a CI pipeline that generates an entire OS image with your Flutter app in minutes with GitHub Actions. And if you are creative and think outside the box, you can achieve basically anything you want without having to learn embedded UI frameworks like Qt, which is huge because a lot of companies started dropping Qt because of lack of engineers, and they moved into HTML, which created a different set of issues that you already know how it works. And with Flutter, you can just take the cheapest one, 2 gigs of RAM, run the app, it will be smooth, no issues, no problems. So, what Flutter did for us? It essentially saved us and made the entire thing possible from the operations perspective. It made it possible for us to quickly scale our business and focus on what's really important, which is driving sales and building new products. The app has processed more than 7,000 orders already, and it's still running strong without major issues. This means over 40,000 individual boards were dispatched from the simple app that I've shown you. And right now, we can also quickly add new processes to our app as we grow, because we own it. Most of the stuff mentioned today was relevant when I submitted the talk. It was a few months ago. Right now, we have 12 distributors, and we are not doing so much retail anymore. But there is no problem in taking the app that we already have and building a tool that easily allows you to pack 1,000 items in a single order. It would just take a bit of UI finesse, but I don't need to deploy an entire CRM and pay someone for it. So a few last takeaways. You can explore our lineup at pineboss.io. We have a lot of interesting boards if you'd like to try them. I strongly recommend getting a Pi 5 just to explore what is possible today with embedded Flutter. And I really hope that together we can make Flutter a go-to UI framework for embedded projects. Because I've seen too many clients struggling with other technologies in the past. And those problems simply don't exist in Flutter. Thank you. So, any questions, maybe?
So why would we choose this one over Android devices that are very cheap? Why should we choose these devices over very cheap Android devices? Because we build other apps?
Those cheap Android devices are obsolete the moment you get them. And Raspberry Pis also run Android. So you can very quickly compare how much faster embedded Flutter is than a low-cost Android device.
Can you run APKs on those?
Yeah. On the, if you install an Android image on the Pi 5, you can run APKs as well.
Okay.
So for every question, you get a board, essentially. So yeah, I think you are first.
So my question is, how do you identify if there are two and more hardware devices connected to your Raspberry Pi? Because you said that you will have to work on the keyboard events. So is there a standard that everyone will get their own set of keys that they can work with?
So essentially, you have a listener that handles all the input events. And when you scan a barcode, it sends a sequence that is easy to identify. So you have a single string with a EAN code that always has the same length, and it's finished with an enter. So you simply parse that. For the 5.
A quick question is more related to the device, not the other, but so where I came from is like really super hot. So this is the kind of device like the Pi 5. Which temperatures does this allow?
I mean, the CPU itself consumes up to 15 watts. But even in a simple example like this, it has a standard laptop blower style cooler.
Okay.
That is PWM controlled. And the cooler costs $4. So it's like cheap.
Yeah, I mean, mainly because when I come from, we can be like 45, 50 degrees on the street. Okay. So if you place a camera, that's why I was thinking something like...
It will work, and for a fact I tested it, because the devices are sold for Teslas. I have a beta tester in Dubai. So it's like 50 degrees ambient, and it's like the device is rated to operate up to 70 degrees ambient.
Oh, perfect. Thank you.
Grab a board. Maybe. Oh, yeah.
I'm here. Can you go into detail how you deploy updates to the applications, how you create the ISOs or some images?
You can, if you use the tooling provided by Snap, you get an app bundle, and then you can simply image the Pi with a new version, or you can simply download the package to the device and install it.
So, sorry, this is the last live question.
Yeah.
On the other hand, Mike will still be here.
Yeah, just...
And maybe you can flirt yourself to get one of those. He's a nice person. All right, so in about 8 minutes, we will have another talk here. Before that, I think you should all stand up, stretch your legs, and decide if you want to go down here or go up again. Thank you all, and thank you, Mike. All right. Hello and welcome back to the studio stage. So before we begin, another quick reminder, there's 2 cameras there. Please don't stand in front of them. And please help make sure that people don't stand in front of them if they come in after this. Okay, so for another great talk, we have Alex with the talk Flutter and Threads. So please give it up for Alex.
I need a glass of water first. Huh? All right. So, hi everyone. And I want to start with just a bit of a story. Because a while back, I had a performance issue in my app. And for the life of me, I could not understand what was actually going on. And deep down, I realized that there was a behavior in Flutter that I did not understand. So I managed to reduce it to a minimal reproduction example, which I hope you will be able to read on the screen. And my question for you guys is, what will this code print on my Android phone? So the first line is I start a timer, essentially, with that time, that now, that milliseconds. Then I run a loop, 1, 2, 3, and I run a 10 seconds calculation, like there's a heavy task taking 10 seconds. I run it 3 times using compute. And then I print the timings for each of the calculations. So first answer could be, you have no idea, you don't know what is compute or anything, and that's totally fine. You're in the right place, don't leave yet. The second answer could be, you think that the first calculation will finish in 10 seconds. Second one in 20, third one in 30 seconds. Answer C would be, you think they will all finish in 10 seconds. And answer D would be, you think they will all finish in 30 seconds. So I'll give you 2 minutes, chat with your neighbor, have a go of what you think the solution is. Maybe just raise your head a little bit if you need to see on the TV. You got 2 minutes, and then show of hands, I'll ask like what you think the answer is. Hmm? Yeah. You were the... Oh, I'm still on. Well. Yeah. I recognize you. All right, so I think the 2 minutes are mostly up. So, show of hands, who voted for answer A? Okay, some people. Who voted for answer B? Okay. Who voted for answer C? Oh, kind of the majority, I guess. And who voted for answer D? Okay, so it's still pretty evened out amongst the 4 answers. So I voted C myself, but I heard it by someone like I would not be giving this talk if it was the answer that I would think it would be. The answer was actually D. 30 seconds, 30 seconds, 30 seconds. So before we dive into why that was the answer, just quickly introducing myself. I'm Alex. I'm the app performance expert at a company called Theodo Apps. It just means that I help projects and clients with performance issues. I'm also the creator of a tool called Flashlight to measure performance of mobile apps even in production and get a performance score attributed. For example, here, measuring scrolling performance of this cute Flutter app. And so, on that note, welcome to Flutter and Friends, and we're going to talk about Flutter and Threads. And you've seen that animation. It's the first time that I'm using Keynote, and I just love that animation. So what we will learn today, so first we will talk about what is threading, like really just go back to the basics of how threading actually works. Then we'll talk about how Flutter uses threads to build frames. Then we'll talk about multi-threading in Flutter. And finally, at the end of it, we'll go back to the puzzler at the beginning and offer an explanation of what was going on. So first, what is threading? So really, threading, the talk, it's all about the CPU, right? The really hardware, like central processing unit, because ultimately, the CPU is what actually runs your code, right? You usually write Dart code, and when you ship your apps, it usually gets compiled to machine code that can be read by and executed by the CPU. And historically, CPUs were really good. CPUs could only run actually one thing at the same time. So you could essentially draw a timeline of what your CPU is doing from, I don't know, 0 milliseconds to 150 milliseconds. So from 0 to 50, it could be running some code from your app, then maybe sleeping for 50 milliseconds, then running some other code from your app. But we all know that our phones can actually do multiple things at the same time, right? So actually, nowadays, modern devices, including phones, have several CPU cores that allow them to actually do multiple stuff at the same time. So while maybe core 1 on your phone is running some code from your app, maybe core 3 is handling notifications from the Android system, and maybe core 4 is doing some work with the messaging app receiving a text. And that's how basically your phone is doing multiple things at the same time. So coming back to just stuff from our app, you could think, yes, but as an app developer, how can you actually leverage such power? Because maybe, I don't know, you have like a very big, expensive task that you need to run, and you'd like to utilize the power of having multiple cores to do multiple things at the same time. Actually, by default, apps can only use one core at the same time. Really by default. And the answer to how to leverage such power is really threads. Because basically, your app will, by default, have what we call main thread. And that main thread will, by default, run all of your code. But that main thread can actually delegate some tasks to another thread by spawning, for example, a new thread. Here, the main thread is spawning a new thread too, which can run the expensive task in parallel, because it's going to run on core 2, for example, which means that it can, all the stuff that it was doing on the main thread, it can delegate it to another thread, and basically your app actually runs faster. So threads is really the answer. Like usually, most of our apps have multiple threads to do stuff in parallel. The question that could arise from this, the really trick question, would be, can we actually have more threads than cores? So most apps actually have dozens of threads usually. But what happens if they all run at the same time? Let's say for a moment that your phone has only 2 cores, and you want to run another thread that you call Thready Mercury. Kudos to my colleague Guillaume for that joke. To play some music on the phone, and then thread Jaspr to make the phone vibrate. So logically, you would think that maybe the phone is just going to wait for main thread and app thread 2 to finish their work, and it's going to run Thready Mercury and thread Jaspr just at the end of it. But since historically CPUs, usually you run only one thing at the same time, actually CPUs are really good at faking parallelism. So it actually looks kind of like this. So Thready Mercury, thread Jaspr, app main thread, app thread 2, they're all competing for the same CPU power. So what happens is the CPU is really good at saying, OK, you get 15 milliseconds, then you stop, I interrupt you, and I go to the next one. And so by default, you can actually assign priority to threads, but by default, it's going to look a bit like this. Like it's going to do a bit of thread makery, then made thread, then thread ester, etc. So it all gives you the impression that your CPU is doing really 4 things at the same time. All right, that was an introduction about what threading is. Now let's talk about how Flutter uses threads to build frames. So when I go to conferences, I usually see a lot of speakers demoing really beautiful apps that they've made, etc., with like shaders and gradient and everything. And so I thought I would do the same, but turns out that my Flutter skills are not that great. So this is the fantastic app example that I'm showing, just a Flutter logo on a pink background. And it's just animating up and down. But I want to go back to really how does, we animate the logo and it gives us an impression of really smooth animation. Like how does that actually work under the hood? And how that works under the hood is really that, well, basically an app is like a movie. A movie is animated pictures and they're animated fast enough to give you an impression of smoothness. Apps are basically the same. So you get, for example, your first image, frame 1, with your Flutter logo at the top. Then you start another picture with the Flutter logo descending a little bit. Then frame 3, etc., etc. You get the gist until you get to the bottom, and then you repeat the process. And you need to do that fast enough to give you an impression of good smoothness. And fast enough usually is defined by this number, 60 FPS, 60 frames per second. So actually, modern phones can run also at 120 FPS, but it means that every second you're supposed to be displaying those 60 images to give an impression of smoothness. So really, really heavy maths here, but that essentially means that you get 1 second divided by 60 for each frame. So every 16.6 milliseconds, you need to draw a new frame. And that's how you get really good smoothness and performant apps. So before we go to how Flutter actually does that, we need to talk about a big word. I mean, I think it's a big word. I want to talk about rasterization. Because I've seen this word in the docs a lot of time, but it was hard for me to really grasp the concept. So my mental model of what rasterization is, or end goal, is really to display pixels on the screen. We have a Flutter logo, we want to display the pixels for the Flutter logo. But when we write code, we're basically writing an abstract representation of what we need to draw. So rasterization, essentially, it's matching that abstract representation to actual pixels on the screen. So for example, we could be saying like, oh, I want to draw a triangle here, a red triangle. The screen is like, I just want pixels, dude. I don't know what a triangle is. Just give me the pixels. So rasterization is really this process of transforming the representation of the view, like a triangle, to actual pixels that will be displayed on the physical screen. All right, so let's talk about Flutter and frames. So at the end of the process, like I said, what we want the bottom of the screen, we want actual pixels updated on the screen. And at the top of the process, of course, we have our build method that we write ourselves, right? This is what we know. It outputs the widget tree. And inside Flutter, there is a whole rendering pipeline that actually won't talk into too many details here, but there are excellent talks from Craig Lobbins to talk into more details about this process. But the point of it is to output what they call a layer tree, which is really an abstract representation of what actually needs to be painted on the screen. Kind of like draw a triangle there, draw a triangle there, draw this shape there. And so you might have guessed it, at the end of it, to translate that to actual pixels, we need to have the rasterization phase. And since we're talking about threads, what we need to know is that build and rendering phase actually happens on the Flutter UI thread, which Flutter is creating for us. And rasterization phase happens on the raster thread, like rasterization, you guessed it. So if we put all that in the the scheme that we were using before, let's say we have our frame of 16.666 milliseconds to achieve 60 FPS. So we first have the Flutter UI thread, which is going to run your code, then run the Flutter code to output the layer tree. It's going to send that layer tree to the Raspr thread, which can actually run on another core. And the Raspr thread is going to be responsible to send drawing commands to the GPU and interact with the GPU so that at the end of it, you get actual pixels updated on the screen. And that's one frame. Oh, it's back. Wow. Did you miss anything or? No. OK, cool. Yeah, the screen is maybe not 60 FPS. I don't know. All right, so the thing is, that's only one frame, right? And it's going to happen a lot. So for example, if you're animating up and down, it's going to happen every 16 milliseconds. You're going to get this process over and over again. So talking about performance issues, it's kind of easy to see where things can go wrong. You might remember that the UI thread is the one that's basically responsible for running your code. So this basically can happen. If you run too many things on the UI thread, then the UI thread here for frame 1 takes too much time. And so the frame 1 is going to get missed. And this is when you start to get jank in your app, because essentially your screen wants to have a frame every 16.6 milliseconds, and your app is not able to deliver them. So you can have those issues in the UI thread. Maybe it could be the Raspr thread taking too long. You can actually check the Flutter DevTools for performance to analyze those issues. But as an example, let's have a bit of fun. So it's still the same app as before with the Flutter logo animating up and down. But I added a calculate button. And when I click on calculate, it's going to run an atrociously expensive calculation. It's calculating Fibonacci recursively, which is just a really bad thing to do. And so let's see what's going to happen. So when I go to click on calculate, the background is actually going to change from pink to yellow, just to give you a clear feedback of when the app is actually running the calculation. The Flutter logo animating up and down. I'm clicking. Yeah, I'm clicking again. You can see that clicking and running that expensive calculation is actually blocking the animation. So it was smooth, but it's only when I click, calculation blocks, animation stops, and when calculating stops, the animation resumes. So what is going on under the hood? It's something like this, basically. We blocked our UI thread because we had an expensive calculation, so we cannot render new frames in the 16.6 milliseconds timeline. Actually, here it's kind of exaggerated, so it runs for a few seconds, but you see the gist of it. So what is the solution there? Well, let's talk about multi-threading in Flutter. The common way to do multi-threading in Flutter is to use isolates. And it's really, really simple to use. Like, it's crazy how simple it is to use. Like, the most easiest way to use it is, so we had our expensive calculation called Fibonacci of 42, and we can just wrap that into compute, a function called compute. And so instead of doing Fibonacci of 42, we do a weight compute of first the function name, Fibonacci, and then parameters. And so let's see the result. I click calculate, it's calculating, but the animation doesn't get blocked. I think I do it again. Yes. OK, very simply, we actually solved our problem with running an expensive task. So what's exactly going on? We had we had our expensive calculation running on the UI thread, and essentially what we did was, pay attention, this is where Keynote really pays off. We're running this new expensive calculation in a new isolate, which is basically another thread that can run on another core in parallel. I'm going to do it again because, yes. And so we totally unblocked UI thread and Raspr thread, and so our app can run smoothly. All right, I'm going to make you work a little bit again. So quick question, what do you think will happen? I'm setting a Boolean called did it work to false. I'm calling an isolate with compute, a function called set did it work. And basically, I'm setting the Boolean to true. At the end of it, I print, did it work? So this time, I will give you 1 minute. Chat again with your neighbor, maybe the same one as before, up to you. And then show of hands, we'll see what you think the answer is. Oh. Oh? Oh, well. All right, I think the minute is up. That was a bit less time than before. So who thinks the Boolean will print true? Wow, almost no one, or maybe no one there. Who thinks the Boolean will print false? Wow. Who thinks the code will crash? You didn't think that was an option, right? Yeah, the answer is it will still be false. The reason for this is that isolates are isolated. Duh, it was in the name. So it means that you really cannot share memory. And you only really communicate by messages. So either the parameters that you send or the parameters that you receive. You can even have long-running isolates sending messages back and forth if you want. That can be really powerful. But if you come from other languages like C++ or Java, you might think, oh, that's kind of sad. You know, you cannot share memory. It's kind of a limitation. Well, it also means that you do get thread safety. So if you don't know what thread safety really is, this is some Java code that blew up in my face 5 or 6 years ago. And it seems impossible to blow up because there is a condition. But when something is really impossible, usually the answer is thread. I have more slides at the end if we have time for it, or if there's a question about it, to explain really what goes on. So up to this point, you might be thinking, OK, Alex, you know, I don't have 10 seconds calculation in my app. So do I really need to use isolates, or why would I use them for? Well, remember that you only have 16 milliseconds or even less to compute frames. So if you have expensive calculation, I mean, when I say expensive, more than a few milliseconds, essentially, it would be a good idea. And one example for that would be JSON decoding. So for example, there's going to be a movie, well, recording of both versions of an app with a shimmering placeholder. I just changed the colors on the shimmering placeholder for a local flag that I'm sure you all recognize, just to see the issue a bit more. But so let's see what it does. So the left one, without compute, you can actually see that the animation blocks at the end, the shimmering placeholder blocks. And the right one, it still continues. I'm just going to run it another time. Yeah. So this is a simple example, but you could imagine, you know, if you're scrolling in your app and fetching some data, parsing the JSON, decoding the JSON, you might actually put a lot more work on the UI thread, and then scrolling will be laggy. That's kind of sad. You know, we should really have top-notch performance experience. But then at this point, you could be like, OK, but then should I just wrap everything in isolates? Well, first, we saw that you cannot share memory, so that's kind of a limitation. But also, isolates do come with a performance overhead because you have to copy all the data when you create an isolate. And so it adds a bit more CPU overall usage and also RAM usage. So for example, using the tool that I was talking about called Flashlight, okay, this is the smallest screen. I think it's going to be a bit hard to read, but I compared the performance of 10 JSON decode with or without isolate. And of course, FPS was so much better because I was not blocking the frames. But the thing to see is that CPU usage was a bit higher. It was 28% higher in this case. So don't wrap everything in isolates. All right. So now finally, to the last part, let's bring an explanation to the puzzler. Because if you followed up to this part, so this code is running 10 seconds calculation 3 times using compute. So it should do them in parallel, right? So it should really do something like this. Basically, the answer should be 10 seconds, 10 seconds, and 10 seconds. And yet, I said the answer was 30, 30, 30. So I used a tool called Perfetto, which is partly integrated actually in the Flutter DevTools, but that allows you to see exactly what's going on your phone and what each of your cores is actually running. So I checked that on my phone, and this is what I was seeing. Core 1 to 8 were too lazy to do anything. Core 9 was just handling all the work. So UI, raster, and all 3 isolates. So why is that? Well, the explanation for this is essentially that usually, especially on Android phones, all CPU cores are really not the same. Most phones will have, let's say, 4 fast cores and 4 slower cores. So for example, I had fun with C++, and you can actually tell the C++ code to execute on one single core. And so I run the same C++ code on all of my cores, and the difference was kind of crazy. Core 1 to 4 took 3 seconds, more than 3 seconds to execute the code. Core 5 to 8 took less than 1 second, 4 times faster. And Core 9 was even faster. So if you think about how Flutter uses threads to build frames, that's actually kind of hard for a non-native speaker to say, actually, like friends, threads, frames. I'm from France. I don't know. Yeah, if you think about how Flutter uses threads to build frames, you really want the UI thread and the raster thread to run on the best core, right? Because if they can be as much as 4 times more powerful, maybe if if you have UI and raster taking 5 milliseconds to usually build a frame, on a slower core, maybe it's going to take 20 milliseconds, and you're going to miss a frame, and your app is not going to be as responsive as before. And the way Flutter does that is using something called CPU affinity. So CPU affinity is basically matchmaking between threads and cores. So CPU affinity is a way, really deep down at the low level, I mean, you can do that in C++ essentially, to match, to say this thread will only run on those cores. And that's what Flutter does. Under the hood, Flutter actually sorts your physical cores on your phone by performance and assigns threads to them. The fastest cores get the UI and raster thread because they are the most important. The slower cores, technically the non-fastest cores, get the IO thread, which is another thread that I didn't talk about, but it's basically a background thread which can handle image decoding and stuff like that. What about isolates? I would have thought that they would go with the IO thread on slower cores. But actually, isolates really are part of the Dart framework and not really Flutter framework. And they actually, at this point, have no way to define a CPU affinity for them. So by default, on Linux and on Android, by extension, if you spawn a thread and you don't specify its CPU affinity, it's going to inherit the affinity from the thread which spawned it. Well, that was a complicated sentence. But basically, here we usually run, our code runs in the Flutter UI thread. So it has the CPU affinity to set it on the fastest cores. So when we're spawning isolates, it's going to inherit the same affinity. It's also going to run on the fastest cores. So if you remember my phone setup, you remember that I have one fastest core. Core 9 was just a little bit faster than the other ones, so by default, the Flutter algorithm to sort the cores was just assigning UI, raster, and isolates to core 9. Okay, but seeing this, you might also be thinking, okay, but in this case, shouldn't the answer be 10, 20, and 30 seconds? If you remember what I explained during the beginning of the talk, actually, CPUs are really good at faking parallelism. So it's not exactly what happens. I kind of lied. This is not the representation of what happens. What actually happens is this. Core 9 is actually running UI, raster, and then a bit of 1, a bit of 2, a bit of 3, a bit of 1, a bit of 2, a bit of 3. And this is why they all finish in 30 seconds. So this is basically an issue at the moment in Flutter, and luckily it's soon to be fixed because there was a PR that got landed to essentially make it a bit more flexible for weird phones like, so it's a Pixel 8, it's not that weird, with one single fastest core. So thank you. Just for a quick recap, you have only 16 milliseconds to build each frame, and your code usually runs on the same thing that is supposed to output frames. So on expensive operations taking maybe a few more than a few milliseconds, like JSON decoding, you should probably use isolate. And you can analyze your performance with the Flutter DevTools or flashlights. And if you want, you can also scan this QR code. I would be really happy if you leave some feedback. I also have some slides, including additional slides that did not make it, and some other links. Thank you so much for your attention. And yeah, I don't know if we have time for a question.
We do actually have a few minutes for questions, so I'll hand over the mic to here.
Thanks. Great talk. I have a question about how can you know how many isolates you can run at the same time on a specific device? Imagine having like a set of images that you all want to scale down. Can you just unlimitedly run them, or will you run into issues starting too many isolates?
Yeah, so I mean, technically, since the CPU is going to fake parallelism, technically you can. But by default, at this moment, it's only going to run on your fastest cores. So that means even another phone that I have, which has only, well, 4 fastest cores, you can technically only spawn 3 or 4 isolates. On Android, at least, which is the platform I'm most familiar with, you can basically just check that, yeah, command line. It's easy to like script and check all the cores that you have on your phone and what their performance actually is supposed to be. And essentially, it's available in files. That's what Flutter does. It reads from files on your phone to check the maximum clock frequency of the cores. But another note to that is actually there's going to be one big change at some point, is that the Flutter UI thread will be merged with the native UI thread, the platform thread, essentially, which means that this affinity like that will not exist anymore. So technically, we're going to be able to utilize the full set of cores. But that's probably future version.
All right, thanks.
Anyone else? No, okay. Okay, one question. Sorry, here we go.
Thanks for a great talk, and I want to ask some simple question. How can solve the problem with shared memory if you use isolates? What is the more efficient way?
So sharing memory at the moment, I think the only way really is to use FFI, for example, and, well, basically live the Dart ecosystem for another language. Kind of painful. There's a whole issue on that which has been running. If you search, like, I think something like Dart does not have real threads or something like that, you will find that it's an issue from 2019, which has been going on for a while. And you see some people explaining how to circumvent that using FFI.
Okay, this might be a stupid question, but just to ask your opinion. So imagine a scenario, there is an iOS app, the Lottie animation is working, but the screen is not, we are touching the text field, it's not responding, it's frozen. So what could be this? How would you describe this situation?
So the Lottie animation is running, but the screen is not responding to touch. Well, it would be probably due to the fact, well, I'm not exactly sure how Lottie would run, but since it's probably a platform view, it's possible that it's the native Android implementation, which runs actually in another thread than the Flutter UI thread. So maybe the Flutter UI thread is blocked, but maybe that native thread for the Lottie animation is not blocked. So it can still run, but your Flutter UI thread has some issues with prevent it from responding to just calling your on-press responding to events. Because the Flutter UI thread is also responsible for handling the events and calling, well, your functions.
Okay, thank you. I will forward this now to my colleagues. They just asked me this question.
But by the way, I don't think there are any stupid questions.
I think the solution is to move over to Rive. Okay, thank you very much, Alex. Okay. Last question.
Thank you for the presentation. I'm wondering, do you know whether Dart team decided to go with isolates rather than handling threads like in C#, for example? Because shared memory is very important, and for example, in C# you have ability to log a thread for a moment, and I'm wondering what was the purpose?
I think I'm not exactly sure. I think basically it's all discussed, and there's this massive issue about this exactly, like threading and sharing memory. I'm not exactly sure. I remember the original reason, but it's probably there somewhere. I heard that the overall tech lead of Dart is in there somewhere, so if you catch him, maybe you can ask.
Awesome. No, thank you. He will be around, so you can ask him questions, sorry.
Yeah, they actually started a new pull request for it. So I'm not exactly sure what happened. So they actually wrote a first pull request for the affinity. Then I submitted the issue, and Jonah Williams, who's in charge of the engine, was like, okay, yeah, maybe we should relent that PR. Then they reverted it again, and then they submitted a new pull request, which is still open at the moment. So I'm not exactly sure what's going on, but it should really be coming. And actually, I realized that a lot of Flutter apps on my Pixel 8 phones are not running that well, even though it's a really good phone. And so I'm kind of, you know, there are some apps that I use on a daily basis that I want to see upgraded.
That was a great talk, by the way.
All right, so in about 10 minutes, there will be a short talk from Simon down here. See you in 10.
So let's check fast.
Yes. Oh, wait.
just said.
And hello, everyone. Thank you for coming back. So now it's a quick talk from Simon about accessibility. So please, yeah, accessibility. Quick wins.
Thank you very much. Thank you. Thank you. All right. Hello, guys. Thank you so much for coming here. And as you might have heard here, my voice is a little bit tempered. A little bit of a too energetic meeting with the Backstreet Boys and the Spice Girls in the karaoke bar on Friday. So if anyone doesn't or can't understand anything or something, please just wave and I'll try to accommodate. Or sing a song of the Backstreet Boys and I'll join in. All right, my name is Simon. I work for Markably. I'm from Vienna and I'm one of the organizers of the Flutter Vienna meetup. Here are my socials. And I will go on because this talk is only 20 minutes. So we'll do a very quick wrap up. And this talk is, or the idea of this talk It's really not supposed to be a full workshop after which you'll be able to make the perfectly accessible app. This idea or this talk is really, really based on the idea that I think a lot of people would love to make more accessible apps. A lot of companies would love to make more accessible apps. But the problem is, like, you know how it is. Like, I work in an agency, everybody's in the beginning fully on fire. Yeah, let's make it accessible. Everybody should use my awesome app, it's so great. And I don't know, this TikTok or Tinder for cats or something like this, everybody should be able to use it. But as time progresses and as everything goes by and the budget gets lower, people start canceling stuff. And one of the first things that gets canceled is usually accessibility, because the majority of people don't need it, will not notice it anyway. And my idea, or the idea of this talk, is really to give a very, very low-level entry into this whole topic, to just show how easy it would be to actually make an app a little bit more accessible without much extra work. So like I said, it's really more about the basics, covering the basics, going in that more people can use the app. It's not about making everybody being able to use the app. And hopefully this will inspire you or bring you to a point where you try implementing it, read more about it, and then start really making amazingly accessible apps. So just to cover the basics, what are accessible apps? Apps that can be used by anyone. I will not go further into this because I think the fact that you're here shows that you know what accessible apps are and how important they are. And just to mention a little bit of a keyword, the WCAG guidelines, they're just one of the most recommended guidelines for following accessibility on apps and to implement them. And just so you've heard them, or you can bash them out next time you're at a meeting, there's 3 levels, level AA, and AAA. And they just go from like weakest to strongest. Like level AAA is really, really hard to implement. Like it's really almost impossible to hit it 100%. But the more you implement, the better. And in my opinion, you should always go for an AA at least, like for official stuff. Perfect. Let's talk about the most common barriers like we have as app developers. And of course, one of the first one that comes to mind is motoric stuff, like everything that has to do with your hands, like whether it is you're having issues like really pinpointing stuff on small surfaces, or whether it's like you have limited mobility in some ways. This is something, and I want to say this with all these things, these barriers and impairments. It's not something like, often when we think about accessibility, people think about like very, very strong cases, like cases with really like people that are blind, people that maybe not be able to move at all with their hands and stuff like that. But there's a lot of shades in between. I think this is very, very important. I personally, when I work on stuff like that, I usually think about my grandmother. My grandmother is an elderly lady, like she's awesome, but she has trouble like with her smartphone. She has one of these big ones, and she has a lot of issues with a lot of apps that she really likes and would love to use more, but she can't because some of them are very complicated. So please don't just always think, you know, like I'm really going for this and this example. There's a lot of shades in between. Another one is like a visual barrier or impairment. Basically, like we're talking here not only about like blindness, but also color blindness, low vision, and a lot of steps in between as well. There's 2 more. Hearing and cognitive and learning. To be honest, I will basically blend them out a little bit. The reason for that is that hearing, like most apps that we write, don't really involve that many audio elements. If they do, you know, like it's the typical thing, like there's a video, add subtitles, and so on and so on. But they're not so interesting on a technical level. The other thing is like cognitive and learning. Which in my opinion, like there are some technical things that you can do, like navigational structure and so on and so on, but most of them are more content-based. So it's really more about how you structure content, how you divide stuff up in UI. So we will focus on motor and visual, and with motor, I will quickly summarize it. I rewrote that like just 2 hours ago, because in the morning, like Craig already mentioned a couple of things. So we'll just quickly repeat them and then focus a little bit more on the visual impairments. First, I just want to show numbers because PowerPoint, you need to show numbers, right? So the World Health Organization estimates that about 15% of the global population have an visible or an impairment in general. This doesn't mean, of course, like I said, they're not able to use your app or it's impossible. But this just means, like, for some of them, it might be harder, so some of them impossible, or somebody, it might just frustrating for them. It's actually kind of weird then that 93% of websites and apps are not optimized at all, or only a little bit for people in this range. It's a huge group. So this is just something I wanted to bring to the table. And the reason why I brought the numbers below here are, in my opinion, like, or from my experience as well, like it only takes 5 to 8 hours for a normal app to make it 50% more accessible. And like I said, this is exactly the process that I want to show you in the next couple of slides. So yeah, let's get started with the motoric things. Like I said, motoric things, my grandmother. Like, she has this phone and she just tries to, tap stuff. And one of the most important things here, and it's a super easy rule to implement, is having a minimum size on elements. So basically, make sure that your elements are at least this size. This is the recommended size by the WCAG. You can find this online as well. And of course, it hasn't to be exactly that, but it's a rough guideline. But it just makes it a lot easier for people with mobility issues just to hit something. The second thing is avoid complex gestures or offer alternatives. Like, this is a common thing. You know, you have this app and you make this really cool gesture to control it. But there are some people who really have trouble with this. Like, there's really people who have trouble either with the coordination or have trouble with the actual performance of the task. Another one is, like, provide visual feedback on tabs. This is something often overlooked in Flutter. It's very, very interesting to me coming from a web perspective, because on web you implement hover everywhere. You have always like a focus, a hover, and so on and so on. But I feel like in Dart, of course, because you don't hover stuff, people often forget about these actions and this highlighting of actions. So it's very important, like the inkwell, for example, that just has this ripple effect that goes out, to implement stuff like that if you implement your own gestures. Another thing is, like, typical snack bars. If something happens, show it to the user, because there's some people who have issues, for example, with their sensitivity of their fingers. They don't realize, like, they touched the surface or how hard they touched it, so they're never sure, did it really happen? And in this case, just showing a snack bar, I don't know, everything you did in your life is successful, then it will be a lot better. So it really, really helps just for them to recognize, okay, it worked, what I was trying to do. Of course, like I said, in the motorway, there's a lot of other things. This was just very brief. What I want to focus about is the visual. First of all, because it's the more visual one, it's the one I can actually show you and let you see. The second reason is, and this is something that I'm very, very interested in, I would really love to know how many of you have actually, like, played around with a like TalkBack or another, like, typical device that. Okay, wait. From now on, okay, who has used, like, a voice assistant or something, or not a voice assistant in common sense, but a TalkBack? Or, okay, like, the hands are. Like, there's not many hands here. I will show you in a second. The reason why I wanted to do this is because, me personally, it took me a very, very long time to actually try it out. How would other people, how would blind people, for example, use an application? And this is something everybody, you know, thinks or has a picture in their mind, but the problem is, like, no one has really tried it. And to be honest, this was the reason why I wanted to start this talk, because on accident, my phone broke and the screen was damaged and I had to use it. And I realized how extremely hard it is if people don't optimize it for it. And so, like I said, the goal is really, like, to give you a little bit of a piece of that and show you how we can work with this. So first, we will just dive into, like, some of the smaller things, like just smaller measures that we can quickly fix. One of them is, like, a typical case is poor color contrast. You know how it is. You have amazing designers. We all love designers. They make these super cool, fancy things that look very, very nice. And our designer, for example, she loves to add designs that look like this. There's a very important message, like, I love cheese. And she does this with very nice colors that blend into each other and that look very nice. The only problem is, like, for a lot of people, this is really hard to read. It might be even hard to read for you on the screen with the sunlight. And just for that, like, this is a lot easier to read, and this is more of a recommended version. The reason why I took this in there is because what I hear a lot, and this is one of the misconceptions in my opinion about accessibility, is people say I can't go all in accessibility because, you know, we have a very specific design, we can't change it, we can't make the font huge and the colors popping or something. And the good reason is, like, this is just not true because you don't have to. Of course, it makes sense if you have a little contrast for everybody, but people who really rely on that actually just, people who rely on that actually just use their operating system settings. So all operating systems basically have settings where people who really, really need it, this assistance can activate higher contrast, and it will basically work automatically. Like Flutter will change colors, the operating system will change colors, and it will work. But the reason why I'm having it in here is there's also something for you for Flutter. There is a high contrast media query. Basically, that tells you, did the user enable this setting in their operating systems? Because sometimes the operating system might be off, or sometimes there might be small issues. The next thing is, like I said, font size scalability. Again, there is an operating system setting where you can scale the font size. And the only thing you need to do as a developer is Flutter works with it automatically. Flutter adjusts the font. The only thing you need to do is make sure that the icons scale with it, because they don't do automatically. And the second thing is make sure that nothing gets broken, because this is the typical thing. It doesn't help. We have experience with that. And another thing here is, of course, as a solution, please test your layouts with high scale. It really doesn't take long, but just put it on highest scale, test it, see if it looks good, and fix it if it doesn't. And there's the text scaler off media query property again that you can use to get the scale value the user decided. So if you have widgets that don't scale automatically with it because they're custom made, or you have icons, you can actually scale them with the fonts to make sure everything is in sync. Coming to the big point, like I said, talking about screen readers, I have a short demo for you that I want to show you. And maybe, yeah, I'll quickly show it to you, and I really, really want you to listen to it carefully. So basically, I want to show you how a screen reader works. The basic idea is very simple. You have your phone. You have your phone, and on your phone, like a person who is not able to see like on the screen would just tap on the screen and can flick to the right to go from one element to the next, or left to go back. A little bit like tabbing on your keyboard when you go through a website. This is the first version. If they want to, for example, like submit a button that they just highlighted, they just double tap. The second way is like holding your finger down and then going wherever you are on the screen. It will just read whenever you hover something, and as soon as you want to add it, you double tap again. The second one is easier if you know where elements are. If I know there's a bar down there, a menu bar, it's easier for me to go down than to flick through all of it. Okay, and the good programmer that I am, I created a very inaccessible app. Not actually on purpose, just writing it out, not caring about accessibility. It happened, and I'm very sure a lot of the apps we all write are kind of this. And I just want to show you what one of these apps sounds like if you don't hear anything. Feel free to close your eyes if you want to enjoy it, but you can also leave them open.
Button. Double tap to activate. Button. 1, 2, 3. Button. Double tap to activate.
As you can hear, not very helpful, right? Like we as like people who see the screen, we know exactly what's going on, right? We have a little bit of a carousel. We can switch through it. We have a back and forth button, blah, blah, blah. But for people who don't see this, they're very, very confused by this. The next one I really love, because this happened on accident. You see this small line here? This is a visual separator, where I just misused a thing. And please don't start a revolt right now, because you will see it's very motivating for us Flutter people.
Dash, 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 2, button. Far, far away.
I laughed so hard when I did this on accident. But you see, there's an element actually that's not useful, but it's still read out. And just imagine you don't see this and you hear this, and you're like, what's going on here? Okay. And, oh, sorry, let's start again. Yeah.
I agree to the terms and conditions. Double tap to toggle. I agree to the terms and conditions.
So basically what you see here is, first of all, like I said, we have this button up there that is not even recognized because it's an icon, and the screen reader doesn't know that 3 lines, this icon is in this case exactly a burger menu. Then we have an image completely ignored because screen reader doesn't care about it. Here, this is just a button, button, button. And then we have this awesome line that's just read out as dash, dash, dash. And here we have 2 elements that for us obviously is a checkbox, and next to the checkbox we have the text that goes with the checkbox. Of course, for a screen reader this is not obvious. These are 2 different elements. And so if it says like, I agree to the terms condition, click here or check this, it will not work because you're just clicking on a text. So the question is, what will we do about it? And here like comes the semantic widget. Like one of the things we do for buttons and icons that are not explained, we can use the semantic widget to add some labels. We have the semantic label property on images to detail the images. We have an exclude semantics widget that allows us to tell the screen reader this is not part of like the semantic tree. And we have the merge semantics, which allows us to group things together. I will quickly go into details. The semantics widget is basically very simple. It's just a widget you can wrap around everything. Here, for example, a gesture detector. You can wrap it around and just define a label. So very, very simple, like you would do with an alt tag or like something like this in the web. This really helps a lot, and then it sounds more like this.
Menu toggle button. Double tap to activate.
Perfect. The semantic thing has a lot of properties. I'm just going to list 2 or 3 of them, but please, there's really a long list of them. One of the most important one is the live region. If set to true, this will read out something that appears on the screen. So for example, if you have a snack bar and it appears, it will read out the message immediately, which is very cool. Yeah, then we have image semantics. This is very simple, like just adding semantic label, like an alt tag for images. Then we have exclude semantics. We just wrap it around the widget that we want to ignore. And, sorry, there's one missing, where the merge semantics, you also wrap it around, and then it basically just takes it as a group. And what I want to show you here is like the overworked version of this.
Menu toggle button. Double tap to activate. A bar chart showing my sales image. Go to previous chart button. Double tap to activate. Go to chart number 1. Go to chart number 3. Go to next chart button. Double tap to activate.
Nothing happens here, sadly.
Far, far away, behind the word mountains, far from the country's vocalia and consonant not checked. I agree to the terms and conditions, checkbox.
Yeah.
Double tap to toggle.
So as you can see, it was really, really simple. I just wrapped these few things, and the whole screen is already a lot easier to read, and it just makes more sense. And it really took 5 minutes to implement this. Yeah, like I said, we added semantic widgets, we added semantic labels, excluded the dash visual thing, and we merged the check and checkbox. Yeah, just maybe some small tips. Like I said, we're already wrapping up because it's a very short talk. Just very, very short tips. First of all, one tip I would really recommend is enforce accessibility with widgets. Create a widget that has a requirement on semantic labels. So like this case, I'll make a button, and the button has a required property, semantic label. This means everybody who works with this button has to implement this. And you know how fast it is. You type 3 words in there, and it's already a lot better. Same with images and so on. This is just for you to know that it exists. There's actually like a very nice accessibility tests by Flutter, like provided out of the box you can use. And there's also a very nice package called Accessibility Tools by Rebel App Studio that shows you in your app like problems that you might have with your app. And it also has some scaling factors and stuff like that. Perfect. And you can enable it for the web, just as a small tip, because this is often asked if this is really possible. And here are a lot of awesome resources. I will upload the slides so you can just read after them. And that's about it. Thank you very much.
Thank you very much, Simon. You hear the sirens outside. It's not a train, it's nothing. It's we're just testing out, making sure that if Russia would come, we are prepared. So now we have about 40 minutes break. So please go up and enjoy the Swedish holy sacred fika. You can get coffee, you could probably get cinnamon buns, and see you in about 40 minutes. So welcome back, and I hope you all enjoyed the Swedish fika. So now there's a great talk again by Dominik about native background processing. So please give it up for Dominik.
Hey. Thank you so much. And I must say, as often, as always it happens, especially at Flutter Friends, it's so cool to see so many friendly faces and people that I happen to see on many conferences in a row. And we even have people here back from Flutter Europe, which is also amazing. Anyway, I hope you will enjoy today's talk. And also, I think we are live on YouTube, so for anybody watching us, hi. And yes, please follow along. And if you have any questions, I'll be super happy to answer them later. I'm Dominik. I'm a Flutter GDE. Currently, I'm working at a startup called Visible, where we are trying to do an app that you could call a Fitbit for illness, for ill people. I will talk about this a little bit more, but that's been one of the greatest journeys for me ever, actually. So before we start, I would like to make a little bit of agreement between you and me that anytime you see a QR code, as a proper mobile developer, I will ask you to just scan it. Like, trust me, just scan every QR code that you will see. So this one is obviously just a Twitter handle, but first of all, I will have a question to you, because it always amazes me what kind of apps people build with Flutter, and I think it can be also enlightening to you. So you may come from different backgrounds, like agencies, startups, indie dev, things like that. But I think it's very cool to see other types of apps. So let's switch to the Slido that we have here. I'm gonna keep the. I'm gonna put this on the screen. Not sure if, yeah, it will come up down there. Right, so we can see what kind of apps people build with Flutter. So audio recording, computer graphics, super yacht management, healthcare, enterprise, DAW. I don't know what is DAW. What is DAW? Oh, perfect, yeah. Fintech, medical, nice. Medical and fintech somehow is the most popular. Fintech, yeah. This is where the money is, right? I'm making this exercise here. I'm doing this exercise here mostly just to gauge what kind of topics are you covering. What else do we have here? There's some sleep tracking, educational support, podcast, e-commerce, nice, really good topics. So I will post it later on like social media and things. Give me a second, yeah. Cool, now you can see that. So I hope that by this exercise, like we all kind of see now the high spectrum of things that you need to do, like you can do with Flutter, and in turn, like hence, as a mobile developer, especially when you build for both iOS and Android, and maybe sometimes also for web, you often have to deal with a variety of different topics, like UI, UX, animations, state management, the holy grail, offline support, which is like my little thing and hobby, CI/CD, force upgrading, and also some native, I would say, parts, like permissions, like different dependencies for native. And one thing that I think is often forgotten or like left for later, and which we're going to talk about today, is just background processing. And we saw a couple of apps that like podcast player or maybe a fintech that they oftentimes just need some kind of background processing. And as much as I enjoy the fact that with Flutter, I don't really have to worry about native code. I don't really have to worry about things like CocoaPods too much, or I can write my logic both for Android and iOS in Flutter. I think there is a huge value in understanding how it works underneath. And I used to work as a backend developer in my first job. And back then, background processing was de facto like a day-to-day job. So most of the things would have been done as a background processes. And when I moved to Xamarin and some other cross-platform frameworks, one thing that back then I didn't realize that, but now I realize it, is that these kind of apps were built quite naively, like they didn't have any kind of component of working outside of its life cycle. So oftentimes, when you build a feature, it only runs when the app is shown on the screen. Only when you actually need it, you may find a way to run something in the background when the user is not looking at your app. Maybe you will even offload this to the backend instead of running this locally on the device. And only after, like, I moved to Flutter, and 2 years ago I joined Visible, I had to actually face a challenge of doing a bunch of different things in the background, especially after, so last year, I did a talk about migrating from online first to offline first for our app, and this led to actually having to write a lot of the background processing code. And we have an app, so Visible is a health tracker. We have an armband that you wear, and it tracks your heart rate. And we don't really expect our users to open the app all the time. So for instance, we need to do background synchronization with the BLE accessory. We don't even, like, people may not even open the app for a couple of days, but we still need to sync their data to the cloud for some additional processing. So it was very crucial for us, having a Flutter app, to be able to do some background processing. And like, I think working with BLE in Flutter is a little bit of a challenge of itself. And then on top of that, you also have to solve a couple of different hiccups and tricks that are related to background processing on native platforms. So today I would like to kind of give you a little bit of a 101 to background processing in Flutter and show what are the ways to achieve that. So first of all, knowing a couple of types of apps that we've seen before, we're going to go through different use cases for background processing. Then obviously, I think that's the crucial part of the talk. We'll see what are some ways to achieve that with Flutter. And at the end, we're just going to ask a question. Not sure if we're going to answer that, whether like you should always use Dart or maybe something else for that. Some use cases. So our app, Visible, needs to synchronize out of lifecycle. When the user closes the app, we want to synchronize the data back and forth overnight. So for instance, when they connect their phone to the charger, a couple minutes later, we want to run some synchronization logic that will send their actions and data to the cloud, fetch them, and so on and so forth. And like, if you have this kind of architecture that allows you to queue your actions for later, it's quite straightforward. But then, of course, there's a question how to achieve it, like how to run this in the background. So in our app, we actually have a special debug mode where we can see different background tasks running as a notification. So for instance, in our test flavor of the app, you can see that this is a task that just started, and I can just easily kill my activity, and then the task is still going to be carried out. And it will take about 20 seconds to finish. And despite user actually closing the app, I don't know how about you. I did a poll a couple months ago, but I found that like over half of people actually always kills the app when they leave. Like that was striking to me because I never kill any app unless it fails to work. But it seems that most of the people actually, when they leave the app, they just swipe it away. And on Android, it's not that big of a deal, but on iOS, if you have any kind of background processing requests, they will not be carried out because the iOS will just prevent any background work, aside from push notifications maybe, to run, which is obviously a problem if you want to do any kind of thing in the background. The other case that I think, again, is often forgotten in like Flutter ecosystem, which I think is still pretty young, is that anytime you upload something or download anything bigger, you want to do it using some native APIs that your system exposes for files uploading and downloading. So obviously, if you go to any tutorial online and you try to look for how to download image in Flutter, you will find something that uses HTTP or DO or anything like that to fetch it in Flutter. And that's perfectly right, but again, if the user leaves the app and maybe they go to Facebook or Instagram, the memory pressure is going to be such that it will just suspend your app. So most of the apps, and you will find it everywhere, Instagram, YouTube, OneDrive, Dropbox, Google Photos, especially on Android, they will offload these kind of synchronization tasks to dedicated services or dedicated foreground services to carry out the work. So for instance, here you can see a OneDrive that synchronizes the pictures. Again, Android is kind of easy here. In case of iOS, it's a little bit more tricky, but still there are some APIs on the in the system that allow you to do it. And I'd argue that anytime it's just easier mental model to think about. Anytime you have to upload something to the cloud, it's just easier to detach it from some process that you do and think about it as something that happens outside of your app lifecycle. And the third use case that we also have at Visible is using the BLE accessory. So in a certain way, connecting to a BLE accessory is a background processing task. And in our case, it's especially important for waking up the app when the BLE armband is in the range of the phone. So when the user turns on the armband or when they approach the phone, we want to wake up the app, synchronize the data, because maybe the next time they will be in the vicinity is going to be in a couple of hours. And the same happens, for instance, when you have a app as a key to your car, or maybe you have a smart lock, and the smart lock unlocks automatically when you approach. So they may use BLE beacons that wake up your app, even if it's suspended. And so these use cases are kind of common. If you have a podcast app, maybe, you would like to maybe fetch the data overnight as well, things like that. And having all of these in mind, you make, let's say your client comes to you and they ask you to implement this. You type into Google Flutter background processing or background download, and the first couple of answers, unfortunately or fortunately, I don't know, they are saying in Flutter you can just use isolates to do any kind of background work, which in a certain way is true. Like you can do a lot of the background work in isolates, but I think it's not a complete answer. So let's see what we can actually do, and also we will use isolates to do background work with Flutter. So a couple of ways to achieve that. So for isolates to work, they require Flutter engine to run or Dart VM to run. Your main app runs in an isolate, and you can spin up your own isolate as well. They can be invoked from your main engine that you have in your app. So let's say, I'm going to show you in a second, if you want to do some computation, you can just start a new isolate with a compute function and just create a new isolate. But what is super cool about it, you can just spin up entire new Flutter engine somewhere, and this Flutter engine can have an isolate, and they can communicate back and forth, which is, I think, a really cool thing, especially if you consider things like foreground services, adding Flutter to an existing app, maybe handling different interactions like handling intents from home screen widgets. So there might be several of them running at the same time, communicating to each other in some way. So yeah, this is, for instance, an example that we have. So I'm looking forward to some optimizations to the JSON decode. So if you were to the talk in the morning by Slava, he was talking about optimizing JSON decode. But for instance, one way to kind of work around some of the limitations of JSON decode is just to wrap it with a compute function so that the serialization happens on a separate isolate, which works for us. And when we have huge GraphQL responses, we avoid junk this way. Yeah, so the most interesting part for me, actually, is just being able to invoke the isolate, invoke the Flutter engine from the native platform. And this happens when you get a push notification and you want to run something. So when you set up Firebase messaging, you will see in the docs that you have to have like this top-level function that will be called when a new push notification arrives and the app is not running. At first, it's kind of unclear. Why is that? Like, why do I need to have this function? Why can I just like inline what I want to do when the notification comes? And you will see this in a second. In case of Visible, our app and many other apps, so when we have a foreground service and we have some Dart code that we want to run outside of the app, we also want to spin up a new isolate. Or, for instance, as I mentioned, when you have home screen widgets, maybe you have a notification with a button, an action that needs to do some work, and you have this written in Flutter or in Dart, it may be useful to do it. So let's have a look at a very opinionated example, how you can actually invoke the isolate from the native platform. This example is like a mixture of my work and some work from Martin Hude from Lean Code from a couple years ago. But I think it's going to show you how you can easily, using a little bit low-level components, but at the same time, if you look at any library that does this, they are doing exactly the same thing, just with a different API, different interface for invoking the background work. So we'll go into the code. Let me know if you can clearly see what is shown on the screens. I know that in the back it may be a little bit too small. Sorry about that. So we are having a simple Flutter app here and a main function. So I'm trying to implement this in a way that's easy to explain during a live coding. In real life, you would definitely do it differently. But here, I'm just creating a method channel that I'm going to use to communicate with my native platform. So in Flutter, you create method channels to send some messages to a plugin or your native part of your app. So here, I just created two functions, start and stop. And these functions will just start some foreground service on Android and stop it when I want it. So there's nothing spectacular about it. And of course, you can use Pigeon, you can use Dart FFI, things like that. So we will have two buttons, start and stop. Then, on the native side, we will just handle this method channel call. For simplicity, I'm just using the main activity. Again, for production, you would probably have your own plugin. And here, I just have a handler for start and stop. I would do the same in my Swift code. So I'm going to call start service when the button start is pressed, and so on and so forth. Then, obviously, in the start service function, what I'm going to do on Android, if you want to start a foreground service, you create something called an intent. And then this intent, depending on the Android version, is going to either run a foreground service or is going to run just an Android service. We create the connection with this service, and we obviously have a method already written down for stopping the service. Then, in another class, which we call here computational foreground service, and this is the part that I took from Martin Hude blog post, which I highly recommend. There's going to be a link for that. And here, when the service starts, what we're going to do is that we're just going to show a notification, and we will be able later to modify this notification from a different Flutter engine. So here is the function start Dart service that will actually start my Flutter engine, and the Flutter engine has been, so the Dart service. So we take the Flutter engine from our utils class. That's a perfect name, obviously, for helper that will give us a Flutter engine, and we will create another method channel again. This is for simplicity. I'm using the method channel, but this method channel will receive calls from this engine when I want to update the message in my notification. This is the Flutter utils taken from this example, and we will have, it's a lookup table or lookup map of Flutter engines. So here in the create engine, we will just use vanilla Flutter APIs to create a new Flutter engine. We will take it from the cache, and once we create it, we will just put it into the cache again. We define the entry point, which in our case is the main.dart file, and we also define the name of the top-level function. So this is the part where you need to understand that when you want to invoke the Dart VM, it needs to know what kind of function, what is the main function that you will run. So you can define your custom function. It doesn't need to be main. It can be anything, and you also need to define the file. And of course, at the end, we need to make sure to destroy the engine. Frankly speaking, like this part of the exercise for me is the most exciting because it kind of shows how Flutter engine can be spun up like on demand. Like this is what happens when you have a add to app with Flutter, so existing app, and you want to add a Flutter screen. Or this happens when you, for instance, use any of the plugins for background processing. And we are back on the Dart side. On the Dart side, we make sure to implement this top-level function. We annotated with the pragma that this is the entry point to the program. And here, there is a super simple logic that on timer, every second, we will just update the notification. But obviously, what you could do here is you could try to upload something to the cloud. You could maybe do a database cleanup. You could try to send analytics events, things like that. So essentially, you're having a separate Flutter app, and it's up to you to define how it works. In our case, we are just going to call the update method through the method channel to update the notification. And here's the app running live. I'm starting the service on Android. On iOS, it's going to be a little bit different, but because iOS doesn't really have a concept of background work, as Android has. But here, I'm killing the app, swiping it away. The main activity stops running, but I'm still seeing the debug log showing me that the counter updates. And then I come back to the app reconnects with the service, and I can stop the service right now. So I can see the progress, and I can stop the service right now. So it's again, this is a naive example, obviously, but at the same time, for me, it was a little bit enlightening to see how this works in practice, that there's no magic. It's just a couple of calls, first to the native, and then back from the native to Flutter. And if you want to understand this a little bit more, I highly recommend two resources. First of all, a couple years ago, Razvan Lung had a really good presentation at DroidCon about how isolates communicate between each other. Since then, we had a lot of improvements in isolates, like isolate groups and things like that. And then the other one is the example of adding Flutter to the existing app, where they have to create several Flutter engines, not a single one, but a couple of them, and maintain connectivity between them and communication, which is super cool. And obviously, you will find a plethora of different plugins that allow you to do the background work. I think the most popular ones are Flutter Background Fetch and Work Manager, but there's many more opinionated approaches to do it, how to do it. There are some specific ones, like if you want just to download the file, there's Downloader. If you want to upload, there's Uploader. So it's like a pad left or something. Yeah, highly recommend. So in my case, in my example, I have written down this example in Dart. And for instance, at Visible, we also use a lot of Dart code to run in the background, because we already have our models, our HTTP client, our GraphQL client, connection to the SQLite database, all of the things that we have developed, we have access to from Dart. So it doesn't make sense to rewrite this in any other language. So a couple of background tasks are being run in this Flutter engine that is separated. Tricky part, for instance, sometimes is you have to make sure that if you are accessing or modifying some data, it's not being accessed from your main Flutter app. So there's a couple of checks, and there's no real mechanism for locking. So or semaphores. So you have to do this with some, I would say, trivial checks. But it can be done. So most of that. But my hot take for today is that maybe if you have something very specific, it doesn't really make sense to write it in Dart. Maybe it's actually much easier to write it natively directly. So in the example that I've shown a couple minutes ago, I think the main challenge in understanding that is that you're just jumping between the different environments just to communicate between each other. And of course, you can build a nice, clean API to do it. But at the same time, there's always this cognitive load linked to just switching the context between Android Studio and VS Code, and etc. So at Visible, we just, in many cases, realized that it doesn't really make sense to spin up Flutter engine, which has some cost to it will have some battery impact. And many times it's just easier to write the same code in Swift and Kotlin than to try to make up some abstract interface to make it work. So for instance, even notifications or lack of thereof, like on Android, the notification system is so much more advanced than on iOS, so it just doesn't make sense to build a unified API for that. There are several ways to do it. I would say the most common one is the foreground service that we are using. But recently, Android team has been recommending to use more dedicated, specialized ways to do background processing. They pose some limitations to foreground services nowadays with Android 14 and 15. So they recommend to use short-running background tasks with Work Manager, or, for instance, recently they have added something called user-initiated data transfers. So this is, for instance, when you want to, let's say, upload a picture to the cloud. That's a valid use case for that. On iOS, I would like to have a cricket sound here, because obviously it's as often very different to Android and very limited. So there's like this story that they didn't even have in mind having any kind of background processing in iOS, like back, I don't know, 10 or 15 years ago, when the first version of iOS, the one without App Store, where you would just download the app from the web, like they didn't have a concept of processes having some background work. Everything would happen just in the context of the app. And if you write any SwiftUI or just foundation iOS apps, you will notice this immediately, that the background work framework, let's say, has been built kind of from different, sometimes conflicting ideas. But anyway, obviously they need to have something like that. And the main API that you have on iOS is called BG Task Scheduler. And they have a distinction for short tasks and long tasks. Short task would be just doing like a health check, maybe sending some short burst of data to the server. Long task would be actually, for instance, uploading some pictures. However, these often have some limitations. So what they say, for instance, is there is some machine learning algorithm that will try to learn from your usage patterns, whether they can invoke some background process or not. So if your user doesn't even open the app for a couple of days, it may not let you do, invoke these kind of small tasks. So what happens then often, and this is like a real case from production apps, you may send a push notification with a high priority, for instance, that will definitely invoke some code. And in turn, there might be some limitations. Like, for instance, you may not do many network requests, but there are some ways around it. And in our case, what we had to implement was something called state restoration. And this is an API that's, I would say, it was very difficult for us to understand at first. But right now, we are super happy that this exists and allows us to keep the app running whenever the Bluetooth armband is in range of the device. Just to give you an example of, I would say, the patterns that you have to follow when working with background work on iOS. So for instance, here, we just have a, so this is the app delegate, which is the main entry point to iOS app. And when you want to define some background task, you have to do it at build time. So you cannot dynamically create background tasks. You have to tell App Store, essentially, what kind of background tasks the app is going to do, to perform. And you have to create some IDs for that. So for instance, if you have some database cleaning task, you define it as a handler like that. And the handle database cleaning is typically, if it's a short running task, you have 20 to 30 seconds to finish it up. And you can do all the things you need. And then this is how you schedule the task. So let's say you leave the app, your user leaves the app, and this is the moment for you, a couple seconds, where you can schedule the task. Hey, run it. And in this case, run it when the phone connects to the charger. We don't really need to have network connectivity for that, but we would like to run it when the user connects the phone to the charger. And you can test it in real life if it works. The challenge here is that on iOS, when any kind of background process is invoked by the system, it wakes up your entire app. So the difference here is that it will launch the app with the did finish launching with options, right? So you will have some options in your callback at the start of your app telling, okay, at this time I launched your app in this mode where you can run your background task. But it's not like there's a separate service or separate process running that. It's the same process as your main app. And for us, it was quite difficult because we have, back then, still in the online first times, we had a lot of WebSocket connections. So if the app was still running, all of these WebSocket connections would be connected to our database. So not only we had some costs related to that on the back end, but also the battery usage was quite high. Like all the logging, or we had some periodic tasks that are run when the app is in the foreground. They would still run when the app was not visible to the user, because it was essentially entire app running. So we had to put some checks in place for that. So the trick that we used is called, if you want to look it up, state preservation and restoration. And the specific thing that we have is the Bluetooth state restoration app relaunch. And what it means is that when you are approaching your phone with your BLE accessory, it will wake up the app with a special flag, and you will have some time to assess if it's your device, if it's a device with appropriate characteristics. So for us, it's a heart rate service that we have subscribed to. And we then start the process of monitoring the heart rate. You could easily just stop the processing immediately, like for instance, if you would have a smart lock. But for us, it's important to maintain this connection. And until recently, there wasn't like a really good way to achieve similar experience on Android, aside from constantly scanning for the BLE. But a couple of years ago, they added a similar API on Android that's called companion device pairing. And this is more or less one-to-one of between state restoration on iOS and companion device pairing, essentially meaning you don't really have to, for instance, what we had before was a foreground service that would be periodically scanning for the BLE accessory, and it would just drive the battery, like use the battery very much. And if the device is in the range, we would reconnect and continue monitoring. But with the companion device pairing, it's the other way around. The app gets notified that this accessory is in the range, and you can wake it up. So we have migrated to that a couple of weeks, maybe months ago, and it's been actually having some effect. As often happens, there are some bugs and issues on different manufacturers, especially like Huawei or Oppo or Motorola. They may have some different handling of that, but in general, this is quite solid. And like if you look at the battery usage charts, like they are definitely much better. We don't get these kind of notifications that this app is using a lot of battery anymore that often. But before that, when we would do a lot of BLE scanning, we would get them all the time. Just to maybe recap this a little bit, I think, and I would argue that this is actually a good thing with Flutter, that when you build something and when you actually get to the point where you have to build something more complicated, you just have to understand some underlying platforms. We can coast easily for months, if not years, without even touching the Kotlin or Swift files, not even to mention Objective-C or Java. But like at some point, if you're doing anything more complex, and I would say podcast app is sufficiently complex project to actually have to deal with that, where you just have to face it and understand. In the talk, I just scratched the surface, but in reality, you will have to just spend a couple of hours, if not days, to understand how different systems have the background work exposed to you. And it changes with time. So it's not only between iOS and Android, but between Android 12 and Android 15. Yeah, as I mentioned, there will be challenges that you will have to face. For instance, I mentioned that many people just swipe away the app. On Android, it wasn't a problem until Android 15, which is going to premiere soon, where on Android 15, when the user swipes away the app, you will have very similar experience as on iOS. So many background processes will be suspended or prevented, with some exceptions, obviously. But for majority of the apps, it will mean that they will have to kind of deal with the fact that the app will not be able to run, for instance, nightly. For me, I think the crucial part here was that I just tried to understand how the Flutter engine kind of spinning up works. And after doing that, it was kind of no-brainer just to try it out in our app. And you don't really have to have this abstract APIs like plugins or Firebase messaging. You can, obviously, for ease. But at the same time, it's super easy to get inside of that and understand what is going on underneath, actually. That's going to be all for now. If you want to learn more and kind of get some resources, at the website, there's going to be a short poll for you. Yeah, I like that. I like all the phones up scanning for the QR code. You remember our agreement. So I will ask you for a quick survey, if you could share your thoughts with me. And you will also get navigated to the companion page where you will find some links and resources for that. Thank you so much. That's going to be all for today. I think we have 2 or 3 minutes for questions. So I'm super happy to answer them if you have any.
You mentioned using Firebase Cloud Messaging to wake up your background service. On iOS, doesn't that require user interaction?
Yes, so I wouldn't say that you can wake up the background service from the push notification, but you can perform some work that can happen within this bound. So let's say if you need your app to send something over the network, I suspect it will be possible. But not necessarily you would be able to spin up a foreground service. So the foreground service, they now require user to actually kind of have the app open and interacting with that to start up a foreground service.
When you say they, do you mean Android now?
Yeah.
All right, and that's with 15?
So there's a couple of exceptions. So for instance, when you have a medical app that needs to run, you can ask for the permission to do it. But I think for the majority of use cases where you don't specify, you now have to specify the type of the foreground service, whether it's like a music player or accessory or anything else.
Right.
But for a majority of them, I don't remember the exact types, but you will have to have the app running at least in the foreground to spin up the foreground service. You will not be able to invoke the foreground service from the background.
Right. Thank you.
Anyone else? No.
Thank you so much.
Yes. Thank you, Dominik. All right, in about 11 minutes, we are having the next talk here. Maybe if you want to attend it, try to be a little bit early because they're going to be 2 back-in-back. So we might want to start it like 1 or 2 minutes earlier. Thank you. See you soon.
Thank you so much.
Hello and welcome back. So let's quickly jump into the next talk because we have two back in back. So first up is Raouf talking about the blur effect in Flutter. So please give it up for him.
Hello. Good evening, everyone. Things are about to get real blurry here, and I didn't know we're going to get this stage where it's already very distracting, so I'm pretty sure you can get distracted pretty easily. So for that, I have a very small challenge for you. It's just going to be a mental exercise. I came here prepared with a 50-50 chance that one of you will actually figure out the answer in less than 1 minute. The challenge is very easy. So calculate the sum of all integers from 1 to 100. It is obviously an easy one. It is 1 to 100. So the first one was actually going to answer this, and that's the challenge. Like, I want someone to get the... What? Come on, man, let me finish the question at least. But that was strangely fast. It feels like it was staged. But yeah, I think it might be. But yeah, if you are guessing how did he get it so fast, unless it was staged, I don't know if it is. But and if it wasn't, the only way he would have done it wouldn't be to go iteratively. Obviously, he wouldn't have the time to go through all the numbers in his head in order to get the answer in time. So the solution would be to use something a little bit more analytical, not iterative, and that will be to see a little, to try to find any kind of patterns here. So the pattern we have here is like we look at the number 1. So if we look at the numbers 1 and then 100, we get the number 101. And then 1 plus 99 is 101. And it seems to be the same for all the numbers. So we have a pattern. We have 101, and then it is 100 times divided by 2. And that's when we get the answer 5050 or 5050. Why did I bring this very exact example? It is the story of how a young mathematician was discovered in 1784. His name was Carl Friedrich Gauss, and at the age of 7, the teacher was a little bit annoyed because the students were making a lot of noise, and he wanted them to stay a little bit quiet for at least 30 minutes. So these are really young kids, so he gave them this challenge where he wanted them to get the sum of all numbers, and obviously all of them want to do it iteratively, but in a few minutes, this guy named Carl Friedrich Gauss, just at the age of 7, he found the solution analytically, and from there he was discovered, and then he got the Duke gave him a scholarship to go to a university, and then obviously he became one of the most important mathematicians of all time. But that is old news. We go back to the 20th century. I'm going to the App Store looking for like inspirations or app to look at, like UI challenges to work on. And I'm looking at the App Store, and one of them that caught my attention has nothing to do with saving money. It's all about what you are looking at here, which is this card. This card, you will see it on the main page of the App Store. What it says here, or what is interesting about this one here is the blur. So the blur here merges really nicely with the background. So if we take away the blur entirely away from the picture, as you can see, that is the reason why we have it there, is if we don't have the blur, there is no contrast. And I'm sure you have attended at least one accessibility talk during the day where you can see that without contrast, it's really not, really hard to read. So if we add the blur, we are gaining a lot because we are not wasting, we are not adding something abstract as, let's say, a gradient or shading the text itself. So by adding the blur, it looks very nicely. But if we notice very clearly, the only interesting thing about this one is how it merges with the image by itself. It is gradual and progressive. And when I saw that, I started thinking about how can we do this in Flutter. Obviously, the first thing that comes to mind is progressively doing the blur multiple times and try to do it at different values, at different stages of the image, and trying to get something progressive like that. But I know that it has performance issues, but I don't know exactly what's going on behind the scenes. So the first question that comes to my mind is like, if I do it like that, where I implement multiple blurs, what kind of performance application are going to be there? That's my first question. The second one is, can I do it without using progressively, trying to do this multiple times? Is there any other way with the primitives that Flutter provide for blur to do this? And the final one was like, if I go all in, is there a way where I can do this, where I control the logic and I do it progressively, where I let the logic for the progressivity of that animation? And if we take a look at what Flutter provides, if you look in the documentation, look where you can use blur effect. There are three only classes. One is shadow, the other is mask filter, and the other one is image filter. So if we take a look at the shadow, it's simply a simple soft shadow where you have a rectangular shape or any other kind of shape, and then you have a duplicate behind it, and then when you apply the blur, as you can see, it starts to nicely fades with the background. So that is shadow. We're definitely sure that it is nice, but it's not going to solve our issue. It's not going to take us where we want. So that is one primitive. We can keep it in mind. The other one is mask filter. Mask filter gives us more possibilities because it's always used behind the scenes for the shadow as well. So here, for example, we can define the blur style, and then if I increase the blur for the images, for the normal one, it's blurring the whole thing. And these are shapes that are implemented in Custom Painter. We just provide them with a mask filter to change them. It can be normal. It can be solid, which is only blurring the outside of the content while keeping the object that we painted the same. And the outer one is obviously excluding the object itself, and the inner one is the one that is used. Obviously, it looks different, and it looks a little bit cheaper compared to the others, but it's still doing it entirely on the inside. So you can use it to create some of those design systems that rely a lot on blur or shadows inside. So that is mask filter. The final one is obviously the one we are looking for, which is image filter. Image filter has few parameters. We can change the filter. We can change filter on the x-axis, and it will blur the content on only one way. And then we can do it only on the y-axis, and it can do it in this way. But what we usually do in our regular development is to do it in a combined way, where the end result is going to look blurred, and we're going to lose a lot of details, and that is the noise that we want to get rid of in a background or in a scrolling picture, for example. So these are the primitives. The question is, are they flexible enough with what we have seen, what we're able to change and what we weren't able to change? The answer, you might have expected me to say no, but it's actually very flexible. We can do a lot of tricks with it. So I'm going to show you a couple of them. The first one is called motion blur. So we have only normal blur with Flutter, but if we use the basic building blocks of knowing the fact that, for example, we can do it only on one axis, we can actually implement a really nice motion blur. So here, as you can see, I used linked scroll list so that I can show you the demo here really clearly. So whatever is happening on this list is happening on the other one. So I'm scrolling here. I'm just waiting for the images to load, but you might not be able to see it clearly. So I'm going to try to use the buttons to help me a little bit. Hope all of you can see the difference. One of them is smooth, the other one is not. When you are scrolling so fast, obviously, no matter how fast you are scrolling, there is a limit on how much your eyes can perceive. If we add a little bit of motion blur, and then maybe, for example, now let's do a big jump, you can see the difference much, much better. And the way we do this is obviously still using normal image filter, but the complex part is only just trying to figure out the math for doing the scroll controller. So here I created this very simple parameter that says the max scroll speed, where I'm calculating the speed of our scrolling, so to make sure that if we hit a certain limit, then we enable the blur, but we enable it in a gradual. So we animate the entrance to the blur, and then when we are about to start to cool down, then we start to animate back, so it doesn't feel like there is a glitchiness over there. So this is done with Flutter blur. We don't even have to do anything custom there. Another one would be the lens-like blur. For us, when we think about blur, we only have one image of a blur in our heads. But if we go outside of our bubble, for example, ask people who are in photography, and we ask them what's blur, like for them, it's going to Tokyo, there is a picture, neon light behind you, taking the picture, and the lights somehow become larger. And that is called the lens or Boken, I don't know how to pronounce it, blur. Obviously, we cannot do something exactly the same, but we can try with the basic building blocks of Flutter, because when we use a filter, we can combine it with others called image filter, and then combine. We can combine it with others. For example, there is a dilation one, and then the erode one. So here I have a preset that defines what. So if I reset everything back, this is the normal image. If I change the blur just by changing the sigma on the x and y axis, this is the normal blur we think about. But there is another effect that we can use with the image filter, which is the dilate one. So if we do it, as you can see, it does some edge detection in order to make the pictures a little bit, the objects, it looks at their edges and try to make them a little bit bigger. Obviously, there is another one, which is erode. It can be used for other effects, but here for our example, what we want to do is to enable dilate and then put it as the, is it going to be, let me see, this is the lens blur by the end. It's a little bit of a blur, the normal blur, combined with a dilate effect with specific values. And as you can see, it looks quite similar, but it is not very similar. But this is all using the building blocks that Flutter provide. The next one is the saturated blur. This is something, if you have ever worked with Cupertino widgets, you will know that there are a couple of fidelity issues in Flutter compared to Material. Material is almost like 100% looking like Material, but for Cupertino, because it's not open source and it is Apple, there is no way for us to tell whether this is correct or not. It's always approximation. So one of them is the Cupertino widgets. They all, especially the ones that they have blur behind them, they always feel like a little bit cloudy. They don't feel like vibrant. And the reason for that is because Apple, when they blur something, they always increase the saturation. And the saturation differentiate when you're in dark mode or when you are in light mode. So this is a normal scroll view where here we are scrolling and then we have the blur sigma, as you can see here at the top. When I'm scrolling, everything is looking there as we will expect it. But if we combine it with another filter, and the trick here is just to know that with image-filter.combine, we can combine any image filter. A blur is an image filter, erode is an image filter, and color filter is an image filter. So what we can do is create the matrix that does the saturation first, and then we apply the blur. Obviously, that ends up with a really bad result because you're going to blur some saturated pixels. What we can do is to do the blurring first, and then we apply the saturation on it. So if I use the light preset here, for example, you will see, I hope that you can see the difference. So color filter, if I change it, you can see the saturation. Obviously, these are very small details, but the good news is there is already a PR open. The last update I got about, from it, there was some external contributor who is actually trying to bring this to Flutter right now to implement this in almost all the Cupertino widgets where they increase the saturation for the blurs. The last update was yesterday, and I think it's going to land on a main branch near you in the next coming weeks. The next one is a smooth edge, because every time we think about blur, we are blurring a rectangular area or an area that we clip. So one way we could try to get something smooth, for example, you can see the problem here, right? Like we have a dynamic image, we don't know what's the content of the image, and we have the text, and the text it does not blend really well with the background. I don't think anyone can read it. But if we blur the content, it's actually readable after that. This is a hover effect, and it is the same for all of these. It's now readable. It's now readable. The trick here is to use an image filter, but combine an image filter, one that does like the blurring for the whole content, but then there is another one that uses a different edge effect. But the code here is actually going to explain the whole trick, but it is just composing two image filters, and both of them are blurring this time. But the only difference is the tile mode. One is clamp. The clamp one is the one where you get like a hard cutoff, like for the rectangular ones. But if you combine it with a decal one, you get the benefits of both of them. That's why I'm applying a different sigma for each one of them, and that's how you end up with a really nice background that is very blurry, and we are not using really huge sigmas here, and at the same time we fix the problem with how we can read the content. Another one will be to apply it with a widget called shader mask, and it will allow us to do something quite similar to the issue we had early on. So if you can see here, we have something quite similar to the image where from the App Store one, and we have a lot of control over it. Obviously, we can control the blur level, and then we can control the progressiveness of the gradient, and that is just using a trick. The trick is that we are rendering the same thing multiple times. It works only in cases where it's not really that expensive of an operation to create the widget multiple times. So if I go, for example, here to show you what's happening, is the shader mask is taking the widget and then taking through the alphas, removing anything that is within the gradient. So we have this image, and then we have the other one that is blurred, and then we try to combine both of them together. So that is the trick there, but as I said, the only caveat to that is that we are like drawing and building the widget multiple times. As you can see, we have like done at least 4 examples. Each of them is different, but it's the same blur, it's the same building blocks. It's just about how we combine them with other widgets. So the building blocks as an answer are actually quite very efficient to do other stuff if you figure out a way to hack them together and find a way to use them that way. Yeah, so it is awesome stuff, but as a developer, you cannot go back to sleep if you cannot, like if you're just hacking stuff. You always want an optimal solution where you can control this. You write the logic for defining everything that you are doing. So to do that, we need to break down and understand what is a blur. So let's take a pixelated image. Let's take a pixelated image of Mario, and we want to blur this image. Click blur all the pixels, and then it starts to progressively blur all the pixels. This is the image, and this is the blurred image. What happens between here and there is that we go through each pixel, we take a look at the pixels around it, we do something called convolution, where we read the value of the pixel for each pixel on a different weight. The weight of, for example, if the next one to us is, for example, red, or whatever the color of it, we multiply that with a value here that we are providing. I didn't think that we will not have really big screens, but if you cannot read it here, is that the value here is 0.1. So we multiply it with this value, but that value is going to differentiate as whenever we create a bigger kernel. So the bigger it is, the more blurry it is. So for example here, if I blur it again, it will be much darker because I had some edge cases to handle, and they are literally the edge cases. So the problem here is that I am at the top edge, right? And they need to read the values of the neighboring colors to me. So I have the neighbors from the left, I have the neighbors from the bottom. What happens at the top and what happens on the other side? Well, that is where the edge mode comes in, which is how you handle it. So tile mode, that is the feature that we, when we decide whether it's decal or mirror. So when we say it's mirror, it just like look at the pixel from the other side and try to get that value. So that's when we do a mirror. Then there is a clamp, which will cause the darkness issue, because it will not have any values. It will take something, some sort of a transparent value, and it will end up having some blackness in your final result. And then there is the decal one, which will smoothly try to come up with not a rotated version of the image, but just like you take the image and you put the image next to it, but it's not mirrored. So it's not like if the final pixel of the picture on this side is going to be red, it's not going to take that one, it's going to take the initial one. So that's the difference between the two. But now that we understand what happens in a blur, I want to just take a quick look at something we usually always do. We go to Figma, right? And when we take a look at what the designer gave us, you take a look at the image and they have a blur effect applied on it. You see the value says 68. You copy the value, 68. You go back to your design and then 68. This one is blurred. This one is like, they are totally different. Nothing is similar. Obviously, we have the first clue. This one is called blur and this one is called sigma. Let's feel a little bit more appreciated, because Figma treats their users as like a top-level users, so they give them just like a value called blur, and it doesn't mean anything. But for us, they give us the real meaning, which is the sigma. So there is a formula that converts to a radius. I will have this here, so most of you will have a solution to this problem. But yeah, so so based on the radius, we're going to produce a sigma. The value is not like 2x or 3x. There is like an approximation to it. That is where you have like to use some sort of a tool in order to generate those values. It's not something that you can calculate in your head. There is no way. So for example, here for a blur, yeah, even the UI gets a little bit stuck because we are printing a lot of text. But for a radius of 8.6, the sigma is 5.47. And the bigger it gets, as you can see, the kernel gets bigger. And the kernel means how many pixels are we going to take a look from all of these sides. So you can see the amount of operations that we are trying to do here. And to explain the amount of operations we are doing, when I click on a blur pixel on a small kernel size, you can see the amount of sampling, multiplying, summing, and dividing that is happening. So for example, let's remember just this is a simple kernel that doesn't do anything. You will never use this kernel. It is so small. You usually go with like kernels that are like 10 times bigger than this, or let's say we go to a kernel size of 7 to get a little bit of blurriness in a real-life scenario. We go from 2,000 to about 4,000. So you can see the amount of operation is increasing really, really fast. So now the question is, this is just logic. This is Dart. I can write it in Dart, and then I can end up having some really nice control over what I want. So for that, I implemented, or I got an implementation of Dart from the famous library called image. So I click here on the blur effect. It shall take this very large image, which is realistic for any application, and I click blur. Yeah, as you can see, the app stuck, and these are slides. So I'm not going to increase the sigma irresponsibly because I don't want my slides to broke. Otherwise, I'm not going to have anything to show you today. So I'm going to go to small, keep it with small sigmas just to show you the errors. Like if you have seen the performance talk, you already know the problem here. So in order to fix it, I have to use an isolate so that at least there is a little bit of offloading of the operation to somewhere else that is not the main UI thread. So now I can safely increase the sigma to something really, really, really large, and I will get some more blurred versions of the image. But what you can see here is the blur duration. The blur duration is nowhere near the 16 milliseconds that we have to do each frame. This is always like 10, 20, 30 times bigger than that. So this is useful, but only for like pre-caching, or when you send an image to someone and you want, like for example, when you if you have a messaging application and it supports sending really large images, you want to send another version of the image that is very small and blurred, so that for the users, instead of waiting for the final image to load on their devices, they will see the blurred version of it. So it has some useful use cases, and we have, because it's Dart, we have more control over it. It doesn't mean it's useless. It's just slow, and we cannot use it. In our day-to-day life, we want something real-time and real-time processing, and that is where we need the GPU. GPU does that very, very nicely. So here is an explanation of what's the difference. With a GPU, it doesn't do these things one operation after the other. So for the CPU, it's going through each pixel from the top left to the bottom right, one after the other, taking a look at the neighboring pixels, getting the images, and as you can see, the amount of operations, even though it is an M1 or M3 or M whatever, is still going to be not able to do it in the budget we have, which is 16 milliseconds. On the other side, GPU is literally made for this. They can do this very efficiently because that is why it's called a dedicated processing unit. And in order to understand how Flutter end up giving us real-time blur that is so fast as we have seen, take a look at the code. We start from the part where we use image filter, which is image filter.blur. It's a Dart file, but then straight away it takes us to a file that uses FFI to communicate with a function with the engine. So it seems like we're going to the C side. This one here is initiating the blur, and then we sending it to something called Gaussian filter. You remember the guy, right? From the beginning. It wasn't random. The guy, he's Gaussian. He's finding us back again. So it was named after him. It was named after something else, like Gaussian, what's that? A Gaussian distribution. If you have seen that bell curve that looks like this, it is named after that because when we see the kernel, it is distributed in a way that it's always normally distributed, which is obviously another really more interesting topic. But if you are questioning why Gaussian is included, it's always doing this. And we will explain in a bit why we always do this. But the final bit is where the logic to get the values and multiplying them. That's happening in this file called Gaussian.frag, which is a code that is running on the GPU in a language called GLSL. So what do we want really is how can we do something like this. But before we do that, I just want to explain something about the different types of blur. OK, so I'm going to go real quick here. So the different types of blur is obviously you can blur the image or you can blur like something else. Both of these are totally different. For the one where we're blurring the image, we are definitely, the more we increase the sigma, the more it's going to cause the application to use a lot of resources. With the other one, it doesn't. So Gaussian image, obviously, when we filter it, is just going to sample it down, and then it's going to take a look at the kernel and try to do some logic around it. But this is the kernel, and the nice trick that they do is the reason, the answer to the question why we use Gaussian blur instead of anything else is because Gaussian is separable. So we don't need to actually do the operation with all the sides all the time. What we need to do is, what can be done is something where we can fetch only on the horizontal line and the vertical line, and then we combine them together. And it is mathematically correct because a Gaussian convoluted with a Gaussian equal Gaussian. So this one takes us from a big O of like n squared to n2, which is obviously a huge drop anyway. The last bit is called the GPU lerp hack, where you actually can get a really nice way of, instead of texturing, getting the values of all the values one by one, you can get almost half of them, because this is something that GPU provides by default. Anyway, I'm going to have to go real quick here. When using rect blur, don't worry, you can increase the sigma or the blur radius, and it's going to be hard. To do customized blurs, you have to use something called GLSL. These are some examples. I will leave them for you for later. If you want to do, for example, a box blur, which is another cheap blur, obviously, as you can see, it's cheap. It's not really good. The lens blur, the real stuff here, it's not a fake one. The images are rounded. And glassy blur, that is blur, but it is actually totally different, and it is very noisy. A gradual blur, where we can actually control the values of how gradual it is. This is the final example, I promise you. So here I want to show you what you can do when you have, for example, access to these blurs. I don't think it's working. No, it's working. This is Android. Let's switch to iPhone. This is an iPhone feature. So I'm not sure how many of you have seen this feature before, but when you put two Android devices next to each other, they do this really nice thing. And now that we have control over how we can do that kind of blurring, we can do that. But I'm running out of time, so these are the slides, and this is the code. The code is the slides, because this is a Flutter slide. So if you take a look, you will actually see the code for every example that I've done, because it was already a Flutter thing. I'll have to clap myself here, and thank you.
Thank you, Raouf. If you didn't have time to take a photo of the QR code, I'm pretty sure that Raouf can show it now and also post it in the Slack channel. So quickly, we will try to move over to Jochum, who's going to talk about macros. So please give it up for him, and then in a minute or two, we will see. Yes, thank you.
Hello, everyone. Welcome to my talk about how big macros really are. How many of you expect me to do some, like, showing some code? I just want to know. Okay, well, too bad. I'm not going to go in depth into the code. I'm really sorry. It's only 20 minutes, and macros are really cool, but they're also a lot. There's a lot of things you can do with it, and also it's really experimental. So anything I would show you now, like literally if you would like try it out next week, it would probably already be completely different. So I'm just going to explain the few, which button? This one. The few things. I'm basically going to try to answer 3 questions. What are they? Why are they? When are they? I'm going to sort of answer those questions because they are really weird. I'll do a quick introduction for the people that don't know me. I'm Jochum from the Ploeg. I'm known as Wolvenrain on the internet. And I work as an open source engineer at Very Good Ventures. And while I'm doing my job, I also tend to maintain the Flame engine together with my Blue Fire people. So if you've never heard of me, you now have. And if you did hear of me, I'm really sorry. So why is this slide empty? That's a bit weird. Let me just click. I think I may have forgotten. Oh, wait, no, there's something on there. Oh, well, we know how big macros are. Sweet. That's the end. Sorry, I had to make that joke. I'm really good at making jokes, I guess. No, I'm not. You're probably not here for my dumb jokes, so fine. Let's see what's in store for us. We're going to discuss the following things. We're going to look at what macros are. We're going to look how we can create one. So there will be a tiny bit of code for those who, well, pretty much everyone raised their hand, so yay, we have a little bit of code. And we're going to split that up into 2 phases. We're going to talk about the phases, and we're going to talk about the diagnostic capabilities of a macro. And after that, we're also going to look at how we're going to, or when we could use a macro. And depending on if I go over time or if I have time left, we might also be able to answer some questions, if that's allowed. I might also just go over the 20 minutes. I mean, I'm the last talk here right now, so you guys have nothing else to do anyway, so... Oh wait, there's a panel, never mind. And after that, we have our little goodbye. So, what are macros? Well, I could explain it, and that's also the reason you guys are here, I guess. But we could also just look at the specification document, because people smarter than me wrote that, and they probably know more about macros. So let's just have a quick look. Okay, that's quite a bit of specification about one word. Let's have another look. Yeah, I pretty much understand it now, so it's fine. I can explain this. It's a bit too much for a lightning talk. In hindsight, I thought I could easily fit everything into a lightning talk. I should have submitted that as a full talk, but I'll do that next time, I promise. At that time, I hope the API is also stable, so maybe we can also have some more code. So let's just have a rundown of what macros are. It's a static meta-programming solution. That sounds really cool. That sounds awesome. But it basically just means it generates code while you're still writing code. So that's the static meta part. Like while you're programming, Dart is also trying to program with you. Like it's trying to help you out a little bit. And that basically means like you don't have to, yeah, it builds code as you write code. I should have clicked, my bad. But it also means you don't need to run any commands. Like people have probably used build runner before. You added those cute annotations and then run a build runner command and it generates a lot of stuff. You don't have to do that with macros. It's built into the Dart language, and it can augment everything you basically augment with your macros. So that's really cool again. It does not write to the disk either. So unlike build runner, where it just writes to a file, etc., this macros basically add to your code in like a hidden memory file in that sense. So it is there, you just don't see it, and it works. That's the magical part of it. And it can also provide diagnostics in your IDE. So that means that while you use a macro from a certain package, that macro can provide you with information, for instance, if you do something wrong, or if maybe something is deprecated, they can give a much clearer message on why it's deprecated, or maybe you should extend something or whatnot. We'll get to that in literally the next slide. So let's start by just defining a macro. And to do that, we basically have to define a class that has the special macro modifier. So I'm not sure how many of you were at the pub quiz yesterday, but it was one of the questions like, how many modifiers does Dart have for classes? And I'm pretty sure most of them forgot about macros, because it's behind a flag, so nobody has ever used it before, I guess. So it looks like this. I hope it's a bit visible on the screen, because it's got a lot smaller than I anticipated it. But that's basically how we do it. That's how we define a macro, and the constructor of a macro has to be constant, because it's statically added to the Dart analyzer server. So it can't ever change. You can't have like a mutable macro or whatever. That means that everything within a macro happens in 3 phases. It basically has the first phase, which is the typing phase. In the typing phase, the macro can add new types to your program. So you can define classes, type definitions, and enums. But it doesn't add in this phase like the implementation, the declaration of it. It can only add types that will also be exposed. So it can't do private classes or anything like that. You have the declaration phase for that. And this is the second phase, where a macro can declare functions, variables, and member of classes. So in the first phase, we can say we have a class X, but we don't know the members yet. They get declared in this phase, and in this phase, we can also define how that class function works, or like how the constructor works. And basically, anything you want to do in here, this phase is basically anything you ever need. It has all the features that we want. But there's a third phase, the definition phase. And in there, we can define the bodies of functions, so the real implementations. And we can even wrap existing methods or even constructors of our own written class that we just decorated with a macro to add or inject even more code. So let's say we want to have a validation macro, and we add it on like our data class. So like, okay, when the macro is there, we want to be able to like, when we create this instance of this data model, check if the property email is of the type email, and if it isn't, the constructor just fails. So we don't have to write any of that. The macro could generate and augment our existing code automatically for us. So those are the 3 phases. In this phase, you can also still declare new code, but it will never be public. It will never be exposed to the user. And with the user, I mean the person writing the class, like the data model that I just mentioned. We add the validation macro on top of it. And in this phase, if we would generate a new function or whatever, autocompletion would just say it doesn't exist. It does exist, but it will never be publicly available for anyone using that class. So let's apply those phases, because you guys look like, well, I don't know what you're talking about. So this is the part where I just add a little bit more code to the slides. To add those phases, like it's really, like those phases don't mean anything, and we have a lot of different things we can add macros on. So thankfully, the Dart team provided us with a macro package. So that's what you see at the top there. You see an import packages macros / macros.dart, and those bring interfaces. They expose interfaces like the class type macro, the class declaration macro, and the class, oh, I did it twice, but the class definition macro was supposed to be there. And those are basically interfaces that expose build methods for each of the phase and the type. So the class is the type, and the second part of the word is basically the phase. And they expose basically a build method that you have to implement, and you get all the information you need in that build method. I on purposely did not add the build methods here, because those are like, that's the API that constantly changes, and that they are not entirely sure yet, like, is it enough information or do we want to hide more? So I kept it really simple. And obviously, there are a lot more type interfaces that they expose, ranging from classes to variables to top-level functions to even literally the library part that you can put at the top of the level. You can even add a macro on top of that and just generate whatever you want within that file. It's really cool. Anything can be augmented, and in every phase. So that was basically the bare bones of macros, and I won't go any deeper in that. I'm really sorry. And the reason for that is also because let's just go one back. The reason is also because it's constantly changing. Like the last 2 months, it has been pretty stable, but they don't guarantee anything. Like right now, if you would implement this and you would, for instance, create a file and write something to that file within one of those build methods that I mentioned, it will work. But according to the specification, it should not work. They created the specification, they created the implementation, and they don't align at all. So it's really, really experimental, but it's really cool. Diagnostics is the last really cool part of this whole macros thing. And in this phase, you can basically add information to the user in their IDE. And we have here a little build function. And in this function, as you can see, it basically does a lot of weird things. Like we get this class declaration that's called class, because with double Z's, because with the S it's apparently a keyword, so you can't use that. So they use double Z's, it's really weird. And we get a class type builder. And the first variable is our information, the thing that we just decorated with our macro. And it has things like the class name, the superclass, like what does it extend, or which classes does it implement. You can get all that typing information within your function to do extra logic on top of it. So in this case, if the identifier name of our superclass, aka does it extend something called parent class, everything is fine. Does it not do that, then we report to the IDE, to the user, hey, our schema class needs to extend parent class. So we have this parent class, and if you add this decorator, you're basically saying this class has to extend this schema or this parent class to be able to do something. So maybe we have in another phase we'll generate code that assumes that we are extending from this parent class. So this would just give us an error. It would not compile, etc. We have different severities that we can use, like warning and like information. And that allows you to basically control if, hey, is this code compilable, or do we just want to warn the user, or do we want to provide more information if they look at like the implementation? So that's how diagnostics basically work. Well, then the question is basically, so when do we use it? And to be honest, right now, you should not use it at all. You might have already like assumed that based on how negative I was about it. It's highly experimental and it's far from stable. But it will make our life easier once it goes out of that experimental phase. And the question, like I already mentioned, like this validation package, like this idea that you have like a class, like a data model, it has a few properties, and you add some decorators. Like if people have ever written TypeScript, you might know the class validation npm package. It does a similar thing. We can now also do that in Dart, but instead of it being a runtime thing where it does all the things, we can literally add it to the constructor, etc., and to just have that code in there. And then Dart can determine, do we need that code, yes or no? Like if you never construct this class, for instance, it would never keep it in the compiled binary. So like it doesn't really make it more complex, and these packages can do a lot of things for us. So this is one example that I came up with for like, well, what could you use macros for? Another one is like an ORM. So I was talking about that schema has to extend something. Well, in this case, the example was basically like we have a schema of a certain table, and it has to extend this entity thing because the package requires that. So this is an ORM that would be able to model our class towards like a table and automatically generate select queries and whatnot. So this is really cool, right? This could theoretically work. Well, it already works. Like both of these are packages that I already made. I haven't published them yet because any third-party package that uses macros is unusable in your project, especially if you use Visual Studio Code. They have a JSON file hidden away in the Visual Studio Code extension that only says only the JSON macro and another one are allowed. All the others are not going to work because they are afraid that there will be some cyclic dependency and RAM usage would go up and everything would crash. So they kind of just were like, okay, we are releasing this feature as experimental, but you can't really use it unless you have it all in the same workspace. So any third-party package that's published on popped up that, like the data class, I think it's called data class from Felix Angelov, you can't use it. You can use it. You will just have a lot of errors in your code. It would compile, but your IDE would tell you, hey, this function that you're mentioning, it doesn't exist. So highly experimental, but really cool, once again. We could also replace certain build runner-based packages, because how many of you thought that macros would replace build runner? Yeah, you're all wrong. Because we can't write to files. Like there are packages like barrel files, which generates a barrel file for you, really cool, but it has to write to the file system. Theoretically, you could have a library macro that does all the exports that the barrel file generates, but I don't know if that works. But the barrel file package would use, it needs to write to the file system, and macros are not allowed. They can do it right now, but according to the specification, they should not be able to. But also like the Flutter localization package, like it generates all the localization files for you, like a nice strongly typed API based on like input. You can't give any file input. You can't read from the file system either. There are a lot of things in the specification that are limiting you in what you can do. The only thing you really can do is do anything that you already have in the code. Like you can pass like a string, or you can pass an integer to like the constructor. But you can't pass a custom class, for instance. Like they are really limiting the things you can do with it, because in case people might abuse it. Like, for instance, if you use my package and I add a keylogger in my macro, like you won't see it because I'm hiding everything away in a macro. You don't see anything written to your file system, and I could do whatever. And if you didn't look at the source code, which you should always do, I could steal all your credentials, for instance. Sweet. So they're really trying to limit what is possible with macros, and that makes it not a good replacement for build runner. But there are packages that could be replaced with build runner. I just couldn't find any. Anyway, I don't know how much time I have left. I'm on 30 minutes apparently. Whoops. 30 seconds. Oh, well, perfect, because I'm recapping. So let's recap. Macros can augment your existing code. It can provide diagnostics to your IDE. So if something is wrong, you can tell the developer. And the API is extremely experimental. So long, and thanks for the macros. This was basically my talk.
Thank you, Jochum. So back in the main auditorium, we will now, in a few minutes, have a panel discussion. So we will see you there. If Lucas doesn't want anything, no. See you soon.